What if the universe chose the worst possible moment to test our faith in coincidence? Moments after a massive solar storm erupted from the sun, lighting up auroras across the poles and disrupting satellites, NASA's live feeds from multiple solar observatories went dark. SDO, SOHO, even the Deep Space Network, all offline. At that exact same hour, the interstellar object known as 3I Atlas reached its closest pass to the sun, its perihelion. Was it a system-wide failure caused by solar interference, or something far more deliberate? In a world where data is power, why did every eye on the sun suddenly blink shut? Tonight, we'll piece together the blackout minute by minute, uncover what scientists aren't saying, and explore whether this was coincidence or a calculated cover-up. Stay until the end, because what you'll learn about 3I Atlas might change how you see every solar flare from now on. Cosmic coincidence. What are the odds that a solar storm powerful enough to disrupt satellites, trigger auroras across continents, and scramble high-frequency communications would erupt on the exact day an interstellar object passed closest to the sun? It sounds like fiction. A cosmic setup too precise for randomness. Yet that's exactly what happened when 3 Atlas crossed perihelion. For weeks, astronomers had been tracking its trajectory. A hyperbolic visitor from deep space, glowing faintly green, shedding fragments as it plunged into the heart of the solar system. Predictions said it would reach its brightest phase right as the sun entered one of the most volatile points in cycle 25. No one expected both events to peak at the same hour. At first, the coincidences seemed poetic, nature's timing, not conspiracy. But as data streams began to fail across observatories worldwide, the narrative shifted from wonder to unease. The Solar Dynamics Observatory went silent. SOHO's near real-time imagery froze mid-transmission. The European Space Agency's heliophysics dashboards displayed static placeholders where fresh images should have been. Even independent amateur observatories reported telemetry dropouts. Within a single 15-minute window, nearly every major solar monitoring feed blinked offline. Officially, it was explained away as solar interference. The flares, they said, were simply overwhelming communications bands. But seasoned astronomers knew something didn't fit. Solar storms cause interference. They don't trigger synchronized blackouts across multiple networks built to resist them. Each observatory operates on different frequencies, in different orbits, with redundancies meant to prevent a total information collapse. For all of them to go dark in near-perfect sequence suggested something else entirely, either a shared vulnerability no one had ever noticed, or a deliberate act. That's when archived frames started circulating in private astronomy groups. Before the blackout, several telescopes caught an unusual flare, brief, asymmetrical, almost artificial in geometry, originating not from the sun but from near 3 Atlas's position. Some claimed it was an optical glitch. Others insisted it was too structured, too precise. In one unconfirmed image, a reflection shaped like a ring appeared for less than a second before vanishing. Was it merely a lens flare from solar saturation, or something reflecting sunlight near the object? The debate ignited instantly. Some data analysts combed through the timestamps and discovered discrepancies. Exposure logs didn't align with transmission logs. In simple terms, the cameras recorded images that were never transmitted. Somewhere between telescope and public feed, a gap opened, and what was inside that gap remains unknown. Meanwhile, solar observers noticed another anomaly. Just before the blackout, sensors detected an unexpected surge in high-energy proton flux, levels that usually accompany X-class flares, yet no such flare was registered. Instead, the sun's visible disk showed only mild coronal mass ejections. Where did the extra radiation come from? One hypothesis suggested that 3 Atlas itself, under extreme solar heating, might have vented material rich in volatile compounds, generating its own localized electromagnetic interference. But that would require energy far beyond what an inert rock or comet nucleus should release. Then came the human element, the strange coordination behind the silence. NASA's public dashboards remained frozen for nearly 2 hours. When they came back online, new images skipped over the missing period entirely. The European Space Agency mirrored the downtime. Even Japan's solar observation feeds, typically separate, displayed identical data unavailable windows. For independent astronomers, it was déjà vu. This had happened before. During Oumuamua's solar crossing in 2017, certain spectroscopic data vanished temporarily from open archives, only to reappear months later under restricted access. But this time, the blackout coincided with real-world side effects. Power grids in northern latitudes experienced brief voltage instabilities. GPS signals drifted. Airlines rerouted polar flights to avoid high radiation zones. The space weather warning system, reliant on the very satellites that went silent, was blind for hours. And in that blindness, something slipped past unnoticed. When communications resumed, 3I Atlas's apparent magnitude had changed more than expected. It had dimmed, then brightened, then dimmed again. Some astronomers speculated that it might have fragmented, while others whispered about energy events inconsistent with natural outgassing. What made the situation eerie wasn't just the blackout itself, it was the precision of the timing. The sun's magnetic field was in the middle of a massive reversal, a phase that occurs roughly every 11 years. During this phase, polarity flips cause unpredictable bursts of magnetic tension. And right as that magnetic twist peaked, an interstellar object, the only one observed that year, crossed the exact plane where the sun's equatorial field lines converge. A coincidence or an interaction? Geophysicists later noted a spike in geomagnetic readings across Earth's magnetosphere about 30 minutes after the feeds failed. While correlation doesn't prove causation, the alignment of events was uncanny. Flare onset, data blackout, magnetic pulse, then a global communications ripple. The kind of cascade that typically follows a major solar eruption, but no eruption was officially recorded. Instead, the sun's visible limb showed mild activity, not the monstrous blast needed to cause such disruptions. Something invisible, it seemed, was at play. When the data finally trickled back, analysts found incomplete files. Some metadata tags were overwritten, others bore timestamps from systems not in sync with network clocks. A few researchers claimed that internal archives later contained restored versions of missing frames, yet subtle differences in pixel structure hinted at post-processing. What had been removed or added, no one could say for sure. In forums and late-night scientific chats, the speculation deepened. Could 3I Atlas have released electromagnetic interference that scrambled relay satellites? Could its charged tail, composed of unknown ionized compounds, have temporarily shorted imaging sensors tuned for ultraviolet observation? Or had ground control, fearing cascading equipment damage, manually suspended data feeds? The latter was the simplest explanation, and therefore the one few wanted to believe. Because if it was a manual shutdown, it raised an uncomfortable question. What did they see that made them pull the plug? Patterns emerged in retrospect. The blackout window corresponded almost perfectly to a gap in space weather telemetry from NOAA's Discover and ACE satellites. Both were in safe mode during the event. Safe mode, however, is rarely simultaneous unless pre-programmed. Why would every eye on the sun blink at once? Even the Parker Solar Probe, positioned closer than any human-made object to the sun, switched data relay modes during that period. When its logs were reviewed weeks later, engineers noted an unusually high sensor noise floor and possible transient voltage spike detected as it passed through the solar wind stream. Yet no definitive cause was listed. When confronted, agency spokespeople maintained calm. It was routine, expected under heavy radiation, nothing unusual. But off-record comments from within the heliophysics community hinted otherwise. "We've never had all systems drop in unison before," one researcher reportedly said. "Either the sun gave us something we've never seen, or someone pressed a button." By the time the feeds resumed, the world had moved on to other headlines. The blackout became a footnote, buried under technical jargon and quiet retractions. But the timing, the alignment of cosmic and technological silence, remained burned into the minds of those who watched it unfold in real time. To them, the question wasn't whether something strange happened, but why we weren't allowed to see it. Coincidence is a comforting word. It keeps the universe orderly, predictable, safe. Yet when every lens trained on the sun goes dark at the same instant an interstellar visitor touches fire, comfort starts to look like denial. And as the data gaps widen, one realization grows impossible to ignore. Maybe what failed that day wasn't our technology, it was our illusion of control. Approach to perihelion. For months, astronomers had been preparing for the moment 3I Atlas would reach perihelion, the point in its orbit where it would come closest to the sun, racing through the inner solar system faster than any spacecraft humanity had ever launched. Estimates said it would pass within just a few million kilometers of the solar surface, a trajectory steep enough to vaporize most comets. Yet, 3I Atlas wasn't behaving like a comet. It showed only faint traces of gas, minimal dust, and a strangely metallic reflectivity. As it drew near, telescopes tracking its brightness reported fluctuations that didn't match natural rotation. Instead of the smooth, periodic pulse typical of spinning bodies, its light curve was erratic, almost as if the object were changing shape. Every few days, new data came in from deep space observatories. NASA's Solar and Heliospheric Observatory, SOHO, recorded a greenish glow extending from the object's leading edge. ESA's Solar Orbiter, further out, detected unusual polarization patterns, light scattering off the object in ways suggesting it wasn't just ice and rock. When researchers compared the spectra to known materials, the readings were inconsistent with carbon compounds or silicates. There was something else, an unknown absorption feature around 540 nanometers. At first, it was dismissed as noise, but as the object neared the sun, that noise grew stronger. 3 Atlas accelerated faster than models predicted, not by much, barely measurable, but enough to raise eyebrows among celestial dynamicists. Some invoked outgassing jets, the same mechanism used to explain the mysterious acceleration of Oumuamua in 2017. Others weren't convinced. Outgassing leaves traces, visible tails, spectral fingerprints of volatile gases. Here there was none. And yet, telemetry confirmed it. The object was speeding up, bending slightly off its predicted course. By early September, the countdown to perihelion had become a global astronomical event. Universities live-streamed simulation models, and amateur astronomers set alarms for the approach. Scientists warned of potential signal interference due to solar proximity, but no one expected a blackout. After all, the Parker Solar Probe had already survived deeper dives into the corona. Humanity had watched the sun closer than ever before. Why should this be different? But 3 Atlas wasn't just another object. It had come from interstellar space beyond the gravitational influence of our sun. Its hyperbolic trajectory meant it would never return once it passed through. For some researchers, that made it the perfect test subject, a natural probe carrying information about other star systems. For others, it represented something more enigmatic, a messenger of the unknown. As the object approached within the orbit of Mercury, its visual signature changed dramatically. Its coma, the halo of dust and gas that forms around a sunlit body, remained faint, almost non-existent, but its core began to pulse in brightness. Observers from the Atacama Desert and Mauna Kea noted rapid flickering on sub-minute scales, something no comet or asteroid had ever shown at that distance. Instruments tuned to infrared picked up bursts of heat radiating outward, short-lived and intense. These bursts didn't correspond to solar flares or electromagnetic spikes from the sun. They were localized to the object itself. By now, the scientific community was split. Some theorized that internal cavities within 3I Atlas were collapsing under thermal stress, releasing energy sporadically. Others whispered about a metallic core or artificial structure, a suggestion swiftly dismissed in public but entertained privately among data analysts. The problem was simple. The light curve anomalies were too symmetrical to be random. Something inside was regulating the emission. Meanwhile, deep space monitoring stations noticed strange interference patterns when the object was in view. Ground-based radar arrays attempting to ping it received distorted echoes as though the signal were being bent or refracted by a plasma sheath. One European team claimed to detect a secondary echo, fainter, delayed by microseconds, as if bouncing off a separate reflective surface nearby. They labeled it ghost reflection and left it at that, but others weren't so quick to ignore it. On social media, leaked telemetry graphs began circulating among enthusiasts. These plots appeared to show a rhythmic modulation in radio frequencies centered around 8 megahertz, far lower than cosmic background noise, yet persistent whenever 3I Atlas was observed. It looked eerily like a pulse. Was it just natural resonance caused by charged particles interacting with the solar wind, or something deliberately patterned? NASA never confirmed the signal existed. Within days, the thread vanished from official channels. As perihelion drew closer, 3I Atlas entered a region where the sun's gravity and radiation pressure clash violently. It was a crucible few objects survive intact. Most disintegrate, leaving trails of vaporized elements. Yet preliminary reports from heliospheric cameras suggested that 3I Atlas maintained structural integrity. Its brightness dipped, then stabilized. One physicist likened it to a black box flying through a furnace. The hours leading up to perihelion were tense. Solar activity was unusually high. The sun had unleashed an M9.4 class flare just 12 hours before. Magnetometers on Earth registered tremors in the magnetic field, the auroral oval widened, and ionospheric density surged. Space weather stations predicted radio interference. Still, NASA's live solar feeds remained stable until 3I Atlas crossed the critical threshold. At 1442 UTC, the first disruptions hit. The Solar Dynamics Observatory's ultraviolet imager began showing pixel noise. SOHO's LASCO coronagraph stream froze. The Deep Space Network's telemetry log recorded unexpected data loss across multiple bands. Within minutes, feeds from the European Space Agency and Japan's Hinode satellite dropped offline. It was as if the universe had pulled a curtain. Astronomers watching in real time reported something else. A brief, brilliant flare not from the sun, but from the direction of the interstellar object. For less than a second, sensors saturated, reading a spike of luminosity equivalent to a small solar prominence. Then darkness. Every live channel cut to static. Across social media, viewers thought the streams had crashed. In control rooms, engineers scrambled to reboot systems, but when feeds returned hours later, the timestamp data from that critical window was gone. The missing data spanned exactly the moment of perihelion passage. For an event measured down to the second, this gap was inexcusable. NASA attributed it to automated system protection triggered by radiation overload. Yet, multiple agencies reported slightly different timestamps for the same outage, differing by minutes. In cosmic telemetry, that's a lifetime. Even more curious was what the recovered data later showed. After perihelion, 3I Atlas appeared not to have fragmented or burned. Instead, its brightness profile flattened, steady, almost controlled. Some analysts claim to see signs of angular stabilization, as though it were reorienting itself. An inert object tumbling through space doesn't stabilize, it spins chaotically. Something was counteracting the torque. When independent observatories regained visual lock, they noticed a faint, symmetrical glow extending behind the object, a thin, linear structure resembling a tail, but sharply defined, unlike the diffuse plumes of comets. Spectroscopy revealed an unknown emission line near the ultraviolet range. The official explanation was ionized nickel, but the ratio was off by several magnitudes. Meanwhile, in the background, the sun erupted again. Another flare, perfectly timed with the data blackout ending. To the public, it looked like business as usual. To those watching closely, it seemed staged by the cosmos itself. Chaos bookending silence. The deeper scientists dug, the stranger it became. Magnetic field readings from the Parker Solar Probe recorded shortly after its instruments came back online showed a sudden inversion, a flip in direction lasting only seconds, followed by normalization. Some interpreted it as a transient magnetic reconnection event. Others wondered if the sun had briefly interacted with a highly conductive body, something capable of distorting local fields. But speculation soon collided with secrecy. Requests for raw datasets from several observatories were denied. Portions of the perihelion window were labeled under review. Online repositories displayed placeholder files marked restricted access. The blackout was being quietly rewritten as an operational anomaly. Outside official circles, theorists began connecting dots. Could 3I Atlas have interacted electromagnetically with the sun in a way science doesn't yet understand? Could its structure, perhaps metallic or magnetically aligned, have induced localized reconnection? Or was it something even more radical? An artifact of non-natural origin conducting an experiment of its own? Of course, these claims had no proof. But absence of proof, they argued, doesn't erase the timing. The coincidence of blackout, solar flare, and anomalous data gaps paints a picture too precise to dismiss. The story of perihelion became less about astronomy and more about pattern recognition, the uneasy feeling that something behind the scenes was orchestrated. When 3I Atlas finally emerged from the sun's glare, it was dimmer but intact, moving steadily toward the outer solar system. The world's attention drifted elsewhere. Yet for those who'd witnessed its passage, the silence spoke louder than any official statement. What happened at perihelion may never be known, because sometimes what vanishes in the light tells a darker truth than anything seen in shadow. The instant the lights went out, it began, not with a flash, but with silence. No explosion, no shockwave, just an eerie pause in the flow of information. The heartbeat of solar observation suddenly skipping across every major data stream. One moment, NASA's Solar Dynamics Observatory SDO was broadcasting flawless imagery of coronal arcs twisting across the sun's surface. The next, the screen froze. A timestamp blinked, stalled, then vanished. Across the world, scientists, hobbyists, and live stream audiences alike sat in confusion, staring at the frozen image of a glowing arc. Then blackness. For the first few seconds, most assumed it was routine. The Deep Space Network occasionally dropped packets during high radiation storms, but within minutes, reports poured in from observatories on every continent. SOHO's feed had gone offline. ESA's solar orbiter stopped transmitting. Japan's Hinode satellite returned only corrupted telemetry. Even ground-based radio arrays, far removed from satellite systems, registered static bursts followed by a void of silence. It wasn't just one system, it was all of them. And it happened at the precise minute 3 Atlas crossed perihelion. The blackout stretched across a span of just under 2 hours, but in that brief window, decades of redundancy and international coordination failed simultaneously. Control rooms erupted in motion, engineers checked relays, switching to backup links. None worked. The problem wasn't local, it was systemic. Something had disrupted the entire solar monitoring network. At 1443 UTC, the official logs recorded severe communication interference attributed to solar event. Yet, strangely, no flare was recorded by instruments still operational elsewhere. The NOAA GOES satellites responsible for detecting X-ray flares logged only minor activity. The sun wasn't behaving violently enough to justify such a widespread failure. That contradiction, the lack of a trigger, became the first piece of the puzzle. In Houston, an astrophysicist monitoring SDO's stream noticed something odd just before the cut. A bright point of light appeared near the lower coronal region, not part of any known active region. It flared once, pulsed, then vanished as the feed froze. He captured a screenshot before the stream collapsed. Later analysis would reveal that the anomaly originated not from the sun itself, but slightly offset, exactly where 3I Atlas should have been at that moment. Elsewhere, the European Space Operations Center scrambled to stabilize telemetry from the solar orbiter. Their logs noted spurious data spikes, seconds before connection loss, interference so strong it overwhelmed receivers across multiple frequencies. For context, the solar orbiter is designed to withstand extreme radiation flux. For its systems to collapse so abruptly, the signal would need to exceed solar noise by orders of magnitude. It wasn't just interference, it was overpowering. The blackout spread like a digital contagion. Within minutes, even secondary systems used for solar wind monitoring failed to respond. NASA's DEIS cover and ACE satellites entered safe mode simultaneously. Safe mode isn't triggered lightly. It's an automated retreat designed to protect instruments from damage. But it typically activates after direct particle impact, not in anticipation of one. The timestamps between both systems, identical, down to the second. By 1445 UTC, aurora alerts were being issued prematurely, though no geomagnetic storm had yet reached Earth. Pilots flying transpolar routes reported compass drift. Communication with certain low-orbit satellites flickered. And yet, the sun remained visually calm, its surface placid, unremarkable, almost deceptive. Inside NASA's Goddard Space Flight Center, technicians switched to archive buffers, attempting to replay the final seconds before the blackout. But something strange had occurred there too. The backup feeds, the automatic caches meant to store high-resolution frames, had recorded corrupted files. In several sequences, frames were missing, replaced by uniform gray panels labeled Error Checksum Mismatch. In others, the data seemed rewritten, frames stamped with timestamps from the future, seconds that hadn't yet occurred. It defied logic, as though the system had looped or overwritten itself mid-recording. As panic met confusion, theories multiplied. Some blamed a cascading power surge from the solar storm. Others whispered of deliberate shutdowns, manual overrides from mission control to prevent sensitive data from reaching the public. But that theory raised a question of motive. What could possibly appear on a solar image that would demand an immediate blackout across every observatory? A few independent researchers had their own recordings. Amateur radio astronomers using parabolic dishes to monitor solar radio flux reported a sharp, narrowband signal spike moments before losing lock. The frequency, 8.1 megahertz, was narrow enough to seem artificial. It appeared for 6 seconds, modulated in amplitude like a code, then ceased. One operator in Finland described it as a ping from nowhere. Another in Arizona caught a partial echo, a repeating pulse that decayed exponentially before vanishing. That's when a deeper anomaly emerged. During the blackout, magnetometers in several regions, Alaska, Norway, Chile, recorded faint, synchronous magnetic oscillations. These weren't typical geomagnetic responses. They occurred far too early, long before solar wind particles could have reached Earth. Something electromagnetic had rippled through space faster than the physical solar wind could travel, and it aligned almost perfectly with the moment every solar eye went blind. At 1500 UTC, NASA's internal incident log changed tone. The early solar interference note was replaced with a more cautious data interruption pending review. That phrase, sterile, bureaucratic, hid the growing realization that no one could pinpoint the failure's origin. Ground stations confirmed that all relays and antennas were functional. The disruption hadn't started on Earth, it came from space itself. When feeds finally began to trickle back online at 1618 UTC, the sun looked unchanged, calm, ordinary, as if nothing had happened. But when scientists compared the post-blackout data with predicted models, discrepancies surfaced. Solar brightness had dipped slightly by a measurable fraction during the outage, only to rebound moments after. It was subtle, but real. To some, it suggested that something had briefly occluded a portion of the solar output or absorbed energy directly from its field. And then came the missing minutes. Across multiple systems, from NASA to ESA, the data gap spanned exactly 95 minutes. Not 93, not 97, 95. Identical across every network. That kind of synchronization was statistically impossible if random failures were to blame. Even the timestamps from independent observatories operating on separate systems cut out at the same instant. Later, researchers digging through SDO's recovered telemetry noticed an unexplained header tag embedded within the corrupted files, Eclipse Event Type B. The tag didn't exist in any operational manual. No one could explain who had programmed it or why it appeared only once, and only during the blackout. Speculative channels exploded with theories. Some claimed the blackout concealed an enormous coronal anomaly triggered by 3I Atlas's passage, perhaps an electromagnetic interaction so intense that it risked revealing unclassified sensor data. Others pushed further, suggesting that 3I Atlas wasn't a natural body at all, but something actively responding to solar energy. Whatever the truth, one thing was certain: the blackout wasn't random. The precision of timing, the uniform duration, the absence of preceding solar triggers, it all suggested orchestration. Whether by natural physics we don't yet understand or by human intervention remains the question that haunts the record. After the blackout, NASA released a carefully worded statement. Due to high solar activity and concurrent data processing errors, several solar observatories experienced a temporary interruption. All systems have since returned to nominal operation. No mention of 3I Atlas, no acknowledgement of synchronized failures. But behind the scenes, subtle inconsistencies leaked. A technician claimed that the command sequences for shutting down specific observatory feeds had been transmitted seconds before the blackout, not after. The logs were redacted, but the timestamps remained. Someone, or something, had issued coordinated shutdown commands across international systems. Theories aside, the human reaction was visceral. Watching the sun, the symbol of life and stability, vanish from our collective gaze triggered something primal. It reminded people how fragile our grasp on cosmic observation really is. For the first time in decades, humanity was blind to the very star that sustains it. And when the lights came back on, what was missing was more disturbing than what was seen. The sun hadn't erupted, 3 Atlas hadn't disintegrated, and yet the memory of 2 vanished hours lingered like a dream half remembered. The scientists resumed their work, the data streams resumed their rhythm. But trust in the idea that the cosmos unfolds in plain sight had cracked. Because for 95 minutes, the universe closed its eyes. And no one, Not NASA, not ESA, not the countless eyes turned skyward knows what it saw when it opened them again. Official explanations versus silence. When the live feeds finally flickered back to life, the world expected answers. Instead, what followed was a strange blend of calm, contradiction, and calculated silence. NASA's official update appeared less than 4 hours after the blackout. A short press statement titled "Temporary Data Interruption Due to Solar Interference." It claimed that the loss of imagery was caused by strong electromagnetic fluctuations triggered by elevated solar activity near perihelion. But those who had been watching in real time knew better. There had been no major flare, no CME large enough to cause a system-wide data collapse. The sun had looked deceptively tranquil, and yet every eye watching it had gone blind at once. The language of the report was telling. Words like routine, expected, and nominal appeared repeatedly, an attempt to reframe an unprecedented blackout as a technical hiccup. NASA's Helioseismology Division released a supplemental note assuring the public that no scientific data was permanently lost, though independent researchers quickly discovered that entire chunks of the timeline, especially those covering the 3I Atlas perihelion passage, were absent from public archives. Temporarily restricted, read the new placeholder. Temporarily, in practice, meant indefinitely. ESA issued a similar message citing data buffering errors caused by concurrent radiation surges. But internal communications, later leaked to astronomy forums, told a different story. Engineers described inexplicable data corruption across multiple telemetry channels, with checksum mismatches that didn't correspond to any known fault condition. Several even noted the disturbing uniformity of the outage. Each satellite, despite being in a different orbit and using separate ground stations, failed in the same 120-second sequence. Across agencies, the explanations echoed each other almost word for word, as if rehearsed. The public statements were clean, clinical, and devoid of detail. The silence behind them, however, spoke louder than anything printed. A week later, NASA's Solar Data Center reopened its public portal. But the file tree told a quiet story. Gaps replaced entire blocks of timestamped data. Frames that once displayed real-time solar imagery now bore uniform gray placeholders labeled Error 0xx ECL. The missing data corresponded exactly to the blackout period, when one astrophotographer in Madrid tried to access archived HelioViewer images for the same time frame. He received a message he'd never seen before: access restricted under data integrity review. Meanwhile, journalists began pressing for clarity. A science reporter from The Atlantic asked a straightforward question at a NASA press briefing. Can you confirm whether the blackout coincided precisely with 3I Atlas's perihelion passage? The spokesperson paused, adjusted her papers, and replied carefully, "The event timing overlaps with several phenomena. We don't speculate on correlations without peer-reviewed data." It was a textbook non-answer, the kind that signaled not ignorance but caution. Behind closed doors, the scientists were divided. A minority accepted the official story, arguing that the coincidence was just that, a coincidence. The majority, however, were uneasy. A solar event capable of taking out every major observatory simultaneously should have left measurable traces, magnetic field disturbances, proton flux spikes, or spectral noise across radio frequencies. None of those markers appeared in the data that survived. It was as if the universe had gone mute. Then came the oddest admission of all. A Freedom of Information Act request, filed by an independent researcher in Virginia, revealed internal NASA memos from the blackout week. One of them, dated 2 hours after the event, contained a single line that became infamous: "Maintain low-profile posture until anomaly characterization complete." There was no definition of anomaly, no elaboration, just that phrase, repeated in follow-up threads among senior scientists. Around the same time, rumors circulated about a shadow directive issued to partner observatories advising them not to release raw imagery until it had been validated for data authenticity. That choice of wording struck astronomers as bizarre. Authenticity is not a term used in radiation corrections or exposure calibration. It's used in digital forensics, when verifying whether something has been altered. In the absence of answers, speculation filled the vacuum. Some claimed that the missing frames captured an intense, localized discharge between the Sun and 3I Atlas, something resembling a plasma bridge or arc event. Others suggested the object emitted a burst of radiation that scrambled sensors before physically vanishing from its predicted path. A more skeptical faction accused online theorists of paranoia, insisting the blackout was a rare but natural cascade of communication dropouts caused by the storm's timing. Yet when pressed to identify which storm caused it, silence followed. Amateur astronomers noticed something subtle. The NASA Solar Dynamic Observatory's metadata log showed a delayed restart time, longer than the official downtime reported. In other words, while the public feed resumed at 1618 UTC, internal telemetry didn't normalize until 1642, 24 minutes of unaccounted silence. When this discrepancy surfaced on Twitter, NASA quietly edited its public statement to remove the exact timestamp altogether. At the same time, independent ground telescopes, those not affiliated with government networks, experienced their own anomalies. The Big Bear Solar Observatory in California reported a sudden auto-shutter trigger event at the same moment as the satellite feeds went dark. The camera systems, which had functioned flawlessly for years, suddenly entered emergency protection mode. Engineers reviewing the logs noted that no radiation spike or mechanical trigger occurred. The system simply believed the sun's intensity exceeded safe limits and shut itself down. Within days, online communities started calling it the Great Solar Blackout, but mainstream science outlets treaded carefully, reporting the story only in fragments. Scientific American ran a brief column titled Solar Imaging Anomalies During October CME Storm, omitting all references to 3I Atlas. Space.com declined to comment on the coincidence entirely. It was as if a collective editorial decision had been made. Mention the data loss, not the context. And then the silence deepened. NASA's social media accounts, usually quick to celebrate cosmic milestones, made no posts about the 3I Atlas perihelion. The agency's primary heliophysics channel went 12 days without a single update. For an organization that normally publishes hourly sunspot reports, that gap was glaring. When they finally resumed, the tone had shifted. Technical. Detached, as if nothing unusual had ever happened. In private conversations, astronomers began to describe an unspoken gag field, a zone of conversation that simply stopped at the phrase perihelion blackout. Some insisted it was institutional caution, not conspiracy. Others weren't so sure. One postdoctoral researcher at a European institute reportedly confided, "It's not that we're told to stay quiet. It's that no one wants to touch it. The timing makes everyone uncomfortable." When the Parker Solar Probe's preliminary data was finally released weeks later, it contained a footnote buried in Appendix D. Transient magnetohydrodynamic anomaly registered between timestamps 1441 to 4046 UTC. Insufficient resolution to determine source. To the untrained eye, it was meaningless. But to experts, it confirmed what had been whispered all along. Something physically measurable had occurred at the precise minute of blackout. Yet no one was allowed to name it. The deeper one looked, the clearer the pattern became. Every official explanation followed the same script: acknowledge technical malfunction, deny correlation with 3I Atlas, and quietly restrict the underlying data. And yet, the unanswered questions multiplied. Why did independent instruments fail simultaneously? Why did checksum mismatch errors appear across systems that don't share software? Why were ground-based observatories affected by an event supposedly caused by space radiation? The silence was more than omission. It was orchestration. When journalists tried to contact individual mission scientists, they received no comment under review responses. Freedom of information requests were delayed or denied. Conference sessions that were supposed to discuss perihelion observations quietly dropped the topic from their agendas. Even publicly funded archives were quietly rewritten, their missing blocks masked by newly uploaded, corrected files that scrubbed the gap clean. But data has memory, even when erased. Caches preserved by independent observers, mirror servers, and amateur networks retained fragments of the pre-blackout frames. In one of them, just milliseconds before the cut, there's a glint, a small, sharp reflection, not from the sun, but from something between it and the lens. Analysts tried to model it as a cosmic ray hit or compression artifact, but its geometry defied randomness, a near-perfect crescent tilted at an unnatural angle. The last glimpse before everything went dark. In the end, the public got its story. A harmless solar interference glitch, clean, safe, contained. Yet those who read between the lines saw a different picture of agencies uniting not around an explanation, but around silence. The kind of silence that hums beneath official calm, whispering of something too anomalous to explain and too dangerous to deny. And for those watching closely, the silence itself became the message. The last frame. There's a single image that sits at the center of this mystery. One frame, frozen in time, suspended between knowledge and oblivion. It's the final image transmitted before every major solar feed went dark. The timestamp reads 1442-7 UTC, just seconds before the blackout. At first glance, it looks unremarkable. The blazing edge of the sun swirling with plasma filaments, a faint coronal loop rising like a molten ribbon. But look closer and you'll see it, the anomaly. A sliver of reflected light hanging in the void just off the solar limb, positioned precisely where 3I Atlas should have been. It's small, barely visible unless enhanced. But when contrast levels are adjusted, the shape emerges, elliptical, with a sharp reflective arc unlike any natural emission. Not a flare, not a sensor glitch. The contours are too symmetrical, the edges too crisp. The anomaly appeared for less than 1 second. Then the feed froze, and the universe went silent. At first, NASA dismissed the artifact as cosmic ray interference. It's the default explanation for visual anomalies in high radiation environments, brief streaks of light caused when charged particles hit a camera sensor. But experts noticed something crucial. Cosmic ray strikes appear as straight lines or random pixels, not coherent geometric forms. The light arc in that frame was curved and reflective, consistent with sunlight bouncing off a physical surface. Independent analysts began dissecting the image. One group at a Czech observatory ran spectral decomposition on the still frame and discovered an unusual wavelength spike. Narrow band reflection centered near 550 nanometers, the same range as polished metallic surfaces. The sun doesn't produce sharp peaks like that in its broadband emissions. It was reflected light, from what no one could agree. Within days, the image spread across private astronomy circles like wildfire. Forums lit up with theories, a fragment of 3 Atlas flaring under solar heat, an internal reflection within the Lascaux coronagraph, or something more deliberate, an engineered structure momentarily visible against the inferno. The original high-resolution data file, however, vanished from NASA's open archive within 48 hours. Only the compressed web preview remained. A week later, an edited version appeared in the database, same timestamp, same scene, but the anomaly was gone. The region around 3 Atlas's predicted location had been smoothed out, pixel noise corrected. Metadata revealed the image had been reprocessed under a new software pipeline labeled Image Restoration Batch 14B. No other files in the same series had been altered. Just that one. For some, this was the smoking gun. For others, it was just bureaucratic housekeeping. But to the few who had saved the original frame before deletion, the difference was unmistakable. When the two images were layered pixel by pixel, the missing feature glowed faintly where the corrected version showed uniform background. Something had been there, and someone had removed it. Astrophysicist Dr. Rami Kader, one of the first to analyze the original data, noted that the anomaly's reflectivity changed over 3 consecutive subframes, each just milliseconds apart. That indicates motion, he said in a private paper circulated among peers. Whatever it wasn't stationary. It moved relative to the sun. His conclusion was careful but chilling. Either a fragment separated from 3I Atlas and reflected sunlight at a highly unusual angle, or an object of artificial geometry entered the frame. Shortly after, Dr. Kader stopped commenting publicly. His social accounts went dormant, and his research group's access to the raw heliophysics archive was quietly suspended pending review. His colleagues declined to speak on record. Meanwhile, amateur astronomers began searching for corroboration. Dozens had been streaming the event through telescopic cameras using filters that protect against solar glare. Most caught nothing but static as the blackout hit. But one independent observer in southern Chile operating a solar spectroscope captured something extraordinary. A brief spectral flash not aligned with the sun's emission lines. It lasted only half a second, but showed a blue shifted spike consistent with a moving reflective body accelerating away. The observer, a retired physicist named Javier Montes, sent the data to multiple institutions. None responded. Within a week, his recording was deleted from the cloud storage platform where he'd posted it publicly. This pattern repeated. Independent evidence surfaced, then vanished. A Canadian University observatory reported unexpected lens reflection, only for the post to be retracted hours later. A Chinese observatory mentioned synchronous optical interference in a Weibo update, then removed it entirely. Around the same time, NASA's own LASCO instrument feed archives for that day were replaced by a compressed 6-hour composite, skipping over the missing minute altogether. But while images were being erased, fragments of the truth survived in the most unexpected place: data mirrors. Automated systems around the world designed to cache satellite imagery for redundancy had copied the original SDO dataset before deletion. One of these mirrors, maintained by a German research student, still held the unaltered frame sequence. When reconstructed, the moment of the blackout played out like a cinematic cliffhanger. Frame 1, the sun stable flares visible along its surface. Frame 2, a bright point emerges near 3i Atlas's projected path. Frame 3, the reflection intensifies, elongating into a crescent. Frame 4, static bands appear, telemetry overload. Frame 5, total blackout. 5 frames, less than a second of data. Yet they revealed more mystery than any hour of smooth observation. Theories multiplied. Some argued the light came from a fragment of 3 Atlas breaking apart, its metallic core flashing as it spun. Others suggested the crescent was an optical artifact caused by extreme solar glare. But one theory refused to fade: the idea that 3i Atlas was reflecting light not from the sun, but from something else. To test this, an independent astrophotographer simulated possible light paths. For the reflection to appear as it did, a secondary light source, positioned behind or beyond the object, would be required. The geometry made no sense unless another reflective surface was nearby. A companion body, perhaps? Or something that arrived with it? What unsettled researchers most wasn't just the shape of the reflection, but its timing. It appeared at the exact moment telemetry systems worldwide began to fail, as though the act of illumination and the blackout were connected. Some suggested an electromagnetic pulse, something capable of scrambling imaging sensors, originated from the same point in space as the reflection. And yet, official channels maintained their calm dismissal. NASA's lead heliophysics spokesperson called the claims misinterpretations fueled by data compression artifacts. ESA referred to the incident as coincidental timing under high exposure variance. But neither agency could explain why multiple observatories captured nearly identical anomalies within milliseconds of each other on instruments designed by different engineers running separate systems using distinct software architectures. To those paying attention, the synchronization was the real enigma. How could separate, geographically distant systems all record the same failure pattern at the same instant, unless something external caused it? Something not random, but coordinated, whether naturally or artificially. Quietly, a handful of scientists began an independent inquiry. Using cache sensor data from unaffected instruments, they triangulated the position of the anomaly. The result was startling. The reflective flash did not align perfectly with 3i Atlas's center, but slightly offset, roughly 300 kilometers from its estimated path. That offset, they realized, matched what's known as a Lagrange plasma node, a point where magnetic and gravitational forces balance in complex orbital systems. Could 3i Atlas have triggered a localized distortion there, or had something been waiting in that space? By mid-November, whispers began to spread that the last frame wasn't just a photographic glitch, it was an event marker. A single snapshot of an interaction never before seen, a moment where something beyond our comprehension entered or exited the scene. NASA, ESA, and JAXA all quietly updated their documentation, removing specific time references to perihelion imaging altogether. What makes the last frame haunting isn't the speculation surrounding it, it's what it represents. The final moment before human observation collapsed. For centuries, we've believed that cameras, sensors, and instruments free us from blindness, that nothing in the sky escapes digital vision. But in that second, every machine failed. Maybe it was coincidence, maybe it was physics, or maybe it was the first time we caught something looking back. Whatever it was, the last frame endures, a ghost in the archives, a glimpse of reflected truth buried beneath layers of denial and code. the one image no one was supposed to see, and the one question that refuses to fade. If nothing unusual happened, why did the universe go dark the instant we saw it? Energy bursts and emissions. In the hours following the blackout, when the data feeds stuttered back to life, something peculiar appeared in the telemetry logs. Anomalous spikes in radiation, heat, and charged particles that didn't match the sun's own rhythm. To the untrained eye, they looked like random noise, but to the analysts reviewing the data, they formed a pulse. Short, rhythmic, repeating. A sequence of energy bursts that didn't come from the sun, but from the space just beyond it, right where 3I Atlas had passed through its perihelion. At first, scientists dismissed it as residual interference from the solar storm that had supposedly caused the blackout. But the pattern didn't fit. Solar interference produces chaos, random static. This was order. The bursts followed an interval of precisely 11.2 seconds, tapering off after 12 cycles. Measured across multiple instruments, from NASA's Solar Dynamics Observatory to ESA's Solar Orbiter, the signal repeated consistently, even though the instruments were separated by millions of kilometers. Something had emitted controlled energy pulses from deep within the sun's corona. The first report came from the Parker Solar Probe. When its systems recovered from safe mode, engineers discovered a strange data imprint across its high-energy particle detector, a brief surge of protons traveling in the opposite direction of expected solar flow. In other words, instead of particles being blown away from the sun, a fraction seemed to be moving toward it. A reversal. That's not just rare, it's nearly impossible. At the same moment, Japan's Hinode satellite recorded bursts of X-ray energy originating from a region where no active sunspot existed. Analysts later realized those X-rays aligned with the predicted path of 3 Atlas during its closest solar pass. The emissions didn't match any standard flare signature. They rose sharply, then decayed in a perfect exponential curve, with no accompanying magnetic loop or coronal eruption. It was as if something had briefly ignited, released a pulse of energy, and then vanished without trace. Meanwhile, ground-based ionospheric monitors registered spikes in electron density, tiny localized distortions in Earth's upper atmosphere that lasted only minutes. These were small but precise enough to indicate that high-frequency radiation had grazed the planet. The timing? Exactly 1 hour after the blackout began. That's the time it would take for any high-energy emissions from near the sun to travel through space and brush past Earth. By the following day, NOAA issued a minor geomagnetic disturbance alert, but internally, some of its researchers were baffled. The magnetic flux readings didn't resemble any ordinary solar storm. The waveforms were too clean, too coherent, almost engineered. If this was solar interference, one researcher reportedly said, the sun's behaving like it has a heartbeat. The pattern of pulses began to surface in unexpected places. Radio astronomers scanning the heliosphere for background noise detected faint electromagnetic modulations in the 5 to 10 megahertz range. They were weak, barely above background, but they weren't random. The signal showed frequency drift, like a waveform being intentionally tuned. When converted into an audio spectrum, the pattern repeated with uncanny precision, 12 beats, followed by silence. It wasn't until someone cross-referenced the timestamps that the realization hit. Those bursts occurred during the blackout window, precisely synchronized with the moment the live solar feeds failed. NASA's official response was swift and sterile. Radiation sensors recorded temporary signal artifacts during recovery from safe mode. But independent researchers weren't satisfied. The Parker Solar Probe's magnetometer logs showed something NASA hadn't mentioned: a short-lived reversal of the local magnetic field, followed by a sudden increase in temperature across its thermal shield. That heat spike lasted just 17 seconds, but was intense enough to trigger an automated safety dump, a system meant to protect against direct solar exposure. 17 seconds. Exactly the duration of one of the mysterious pulses. It was as though an invisible wave of energy had passed through the probe, shaking every instrument at once. Yet strangely, there was no sign of damage. None of the sensors burned out. The shield, capable of withstanding 1,300 degrees Celsius, held steady, but the data showed something odd. The heat didn't originate from the sun's side of the probe. It came from behind it. Back on Earth, observatories compared notes. In Chile, the ALMA array detected a brief microwave burst, lasting 0.8 seconds, coming from the same solar longitude as 3I Atlas's trajectory. In Hawaii, infrared telescopes recorded transient heating in the corona, unrelated to any visible flare. The conclusion was unavoidable. Something had released multiple forms of energy, electromagnetic, particle, and thermal, all within the same region and time frame. The data couldn't be dismissed as coincidence anymore. Something near the sun had acted like a transmitter. When researchers plotted the pulse sequence, the intervals revealed a strange numerical symmetry. The gap between bursts corresponded roughly to the rotation period of 3I Atlas's tumbling motion observed weeks earlier, 11.2 seconds per rotation. It was as though the object itself was emitting the energy in rhythm with its spin. That revelation set off alarm bells. If 3I Atlas were just a fragmenting rock, it shouldn't produce rhythmic emissions. Comets vent gas irregularly. Asteroids reflect light passively. Only systems with internal structure, magnetic cores, reactive materials, or, in the wildest theory, technological components could generate such precision. NASA avoided the subject entirely, declining interviews. ESA quietly removed several radiation graphs from its solar orbiter dashboard, citing data recalibration. But cached versions showed clear, undeniable pulses, visible not only as energy spikes, but as harmonic oscillations, as if whatever emitted them had interacted with the sun's magnetic field itself. For days afterward, geomagnetic observatories across the world reported low-frequency tremors, magnetoacoustic waves rippling through Earth's field. Usually such waves are linked to intense solar events, yet no corresponding flare had occurred. Instead, it was as though the sun had resonated with an external force, then transmitted that vibration through space. Some propose that 3I Atlas's composition, rich in conductive metals, might have momentarily short-circuited the solar wind, creating electrical feedback loops. Others pushed bolder theories that the object's structure could act as a resonator, amplifying solar energy and releasing it in quantized bursts. The most radical suggestion came from a small group of plasma physicists who noted similarities between the pulses and what's known as plasmoid discharges, a phenomenon seen in high-voltage laboratories, but never on a cosmic scale. They speculated that 3I Atlas might have generated a self-sustaining plasma bubble when exposed to the sun's magnetic field, essentially becoming a temporary energy engine. Yet one anomaly refused to fit any model. The emissions didn't radiate outward evenly like normal bursts. They appeared to be directed. Parker Solar Probe data indicated a narrow beam of energy concentrated along a specific vector, the same trajectory the object followed as it exited perihelion and began to move away from the sun. The beam wasn't perfectly straight, it oscillated slightly, but it was unmistakably directional. Some scientists argued it was coincidence, a quirk of perspective, or the result of data overlap. But the odds of random solar noise aligning perfectly with 3I Atlas's path were astronomical, and the more the data was cleaned, the clearer the alignment became. If the energy was directional, the question became terrifyingly simple. Toward what? That vector, extended outward, intersected with a region of space roughly corresponding to the orbit of Mars, where several probes, including MAVEN and ExoMars, were operating. In the weeks following the event, both missions reported brief communication dropouts. NASA attributed them to solar interference. ESA said nothing. Then came a subtle yet chilling development. Amateur astronomers observing Mars reported a faint auroral glow, green, diffuse, unlike anything seen before. Mars doesn't have a global magnetic field strong enough to sustain auroras like Earth's, and yet, for 3 consecutive nights, a faint atmospheric shimmer flickered across its terminator. Spectral analysis showed elevated oxygen excitation, exactly what would happen if high-energy particles had swept past the planet. The connection was speculative, but haunting. A wave of energy bursts near the sun, perfectly aligned with an interstellar object propagating outward, and days later, an unexplained aurora on Mars. Coincidence? Perhaps. But even NASA's own timeline couldn't explain the sequence. When asked if the pulses were solar in origin, a spokesperson responded, "All observed emissions are consistent with normal heliophysical activity." But behind that veneer of calm, the internal memos told another story. One leaked communication between ESA and NASA scientists contained a line that few could interpret, but everyone remembered. Energy release sequence confirms non-chaotic modulation. Further discussion off record. Non-chaotic modulation. Those words suggested intelligence, pattern design. The Blackout, once thought to be a failure, now looked more like a firewall, an automatic defense against something the instruments weren't meant to witness. The energy bursts that followed weren't noise, they were signatures, written in radiation, hidden in plain sight. And as analysts continued dissecting the data, one conclusion grew harder to avoid. Whatever 3i Atlas is, it didn't just survive the sun. It spoke through it. Historic parallels. The Blackout 3 Atlas wasn't the first time that the sun and human observation of it had gone inexplicably blind. Across more than a century of recorded solar monitoring, there have been scattered moments where the same story repeats: sudden data loss, strange emissions, and silent recoveries wrapped in official calm. But when you line them up, a pattern begins to take shape, each episode occurring during a rare solar alignment or an unexplained celestial visitor's approach. The earliest known incident traces back to September 1st, 1859, during the infamous Carrington event, the most powerful solar storm ever recorded. Richard Carrington, an English astronomer, was sketching sunspots when he saw two blinding flashes erupt from the solar surface. His observation lasted barely 5 minutes before his instruments overloaded. Telegraph lines across the world ignited, auroras danced over the Caribbean, and yet Carrington's own logbook noted something often overlooked. An interval of sudden stillness preceded the flare, as if the sun held its breath. Modern historians now interpret that stillness as the same kind of pause seen before modern solar blackouts, a momentary electromagnetic quiet before the storm. What Carrington didn't know was that, at that same time, a minor meteor shower, unrelated, or so it seemed, was recorded over the Arctic. Later calculations suggested those meteors had entered the atmosphere from a trajectory now identified with a periodic object outside Jupiter's orbit. A coincidence? Perhaps. But the pattern of simultaneous atmospheric and solar anomalies would repeat, again and again. Fast forward to May 1921, the New York Railroad storm. Telegraph networks failed, fires erupted at power stations, and in observatories from Mount Wilson to Greenwich, solar physicists reported a brief image dropout in their photographic records. For several minutes, telescopes went blank. No sunspots, no texture, just a white, featureless sphere. The plates that survived showed faint circular distortions, as if a lens of invisible plasma had passed between Earth and the sun. Astronomers at the time called it a photographic malfunction. Decades later, physicists realized the distortion resembled what we now know as coronal lensing, the bending of light by charged magnetic bubbles. Then came July 1972, during the Apollo-era rush toward space. The sun erupted in one of the fiercest proton storms ever measured. Satellites temporarily shut down, and the U.S. Navy recorded bursts of electromagnetic noise unlike anything before. Hidden in declassified files released in 1998 was a curious memo. Telemetry gap observed across solar observatories, timestamp coincidence within 15 seconds. The language was eerily familiar, echoing the same precision seen in the 3i Atlas blackout. It gets stranger. Exactly 2 days before that 1972 event, astronomers tracking a newly discovered asteroid, later named 1972 XA, reported erratic radar reflections. The object's surface behaved like a mirror, scattering signals unpredictably. It passed close to the sun just before the proton storm began. Afterward, it vanished completely from radar until rediscovered decades later. Some speculated it had disintegrated. Others noted it returned dimmer, smaller, as if something had stripped its surface away. Every era of observation, it seems, carries its own moment of blindness. The technology evolves, the explanations change, but the pattern persists. When something unusual enters the sun's domain, be it a comet, asteroid, or interstellar wanderer, the instruments we depend on to see it fail, and official records smooth over the gaps. In 2012, during the peak of Solar Cycle 24, a lesser-known event unfolded quietly. NASA's Solar and Heliospheric Observatory suffered an unexpected data interruption lasting nearly 2 hours. The timing overlapped perfectly with the passage of comet Lovejoy, C 2011 W3, through the solar corona, a comet that somehow survived its close encounter with the sun, against all thermodynamic expectations. When the feed resumed, the comet had not vaporized but emerged brighter than before, shedding a trail of ionized particles that glowed electric green. The explanation offered then was simple: instrument overheating. But in retrospect, the event mirrors what happened with 3I Atlas, an object passing near the sun, energy readings spiking, cameras going blind, and data gaps left unexplained. Go back further, and the record grows even older and even stranger. Ancient Chinese astronomers described a heavenly guest appearing near the sun in 312 BCE, a bright green object emitting a dragon's tail of light. Observations ceased abruptly the next day when scribes wrote that the sun's face turned white. Historians interpret this as poetic metaphor, but plasma physicists note that a coronal mass ejection could have produced precisely that effect: a sudden brightening, then a period of low solar contrast. A similar account comes from the Byzantine scholar John of Damascus in the 8th century, who wrote of a wandering star that approached the sun and dimmed its fire, as if swallowing it for an instant. The chronicle ends abruptly. No further solar records exist for the next several months, possibly due to widespread famine and clouded skies following what modern climatologists call the volcanic veil year of 774 AD. That same year, ice cores from Greenland show a massive spike in radioactive carbon-14, proof of an intense cosmic ray event hitting Earth. Some scientists now link it to a solar superflare. Others suspect something even rarer: a magnetospheric collision. What links these moments, 1859, 1921, 1972, 2012, and now 2025, is timing. Each occurred during the ascending or peak phase of a solar cycle. Each coincided with the passage of an unusual celestial object, and each resulted in temporary blindness of human observation, followed by anomalous electromagnetic aftershocks. When 3I Atlas entered that same crucible, the parallels were impossible to ignore. Its trajectory, hyperbolic, inbound from interstellar space, matched almost exactly the inclination of Oumuamua, the first interstellar visitor ever discovered. And just like Oumuamua, it displayed a mysterious non-gravitational acceleration. Both events, separated by nearly a decade, shared a curious aftermath: missing data. Oumuamua's closest solar approach in 2017 was also marked by a brief observational blackout from the Spitzer Space Telescope. The official explanation was orientation limitations. Yet internal memos later revealed telemetry errors just minutes before the data gap, errors almost identical in structure to those logged during the 3I Atlas blackout. Even further back, 1957's Sputnik flare incident, named after the year of the first artificial satellite, recorded a temporary radio blackout across multiple frequencies. The sun had been quiet, yet receivers in Alaska, Russia, and the UK all detected a burst of coordinated static that scientists couldn't explain. It came from the sun's direction and contained repeating intervals at 5-second gaps, the same rhythmic pattern later mirrored by the 3 Atlas bursts. Some researchers began to wonder if these weren't isolated events, but part of a long-term pattern, a cosmic cycle of interaction between the sun and external intruders. Could interstellar objects like 3I Atlas periodically trigger energetic responses from the sun? Or was someone using the sun itself as a transmitter, releasing information or energy bursts through its magnetic field whenever an object of certain properties entered range? This idea, dubbed the Helios Protocol hypothesis, has circulated quietly in astrophysics circles for years. The theory proposes that certain interstellar objects act as resonators that interface with stellar magnetic fields, triggering measurable emissions. In simpler terms, they could be devices, natural or constructed, that communicate using stars as antennas. When 3 Atlas produced its synchronized bursts during the blackout, many saw it as the strongest evidence yet of such a mechanism. But history had already whispered of it before. Each solar blindness incident in the record could represent not chaos, but contact, moments when our instruments unintentionally eavesdropped on cosmic communication and promptly shut down to avoid overload. Of course, skeptics offer simpler explanations: equipment failures, coincidental flares, statistical noise, yet those explanations unravel when examined together. What are the odds that nearly every generation of solar monitoring across entirely different technologies has suffered identical failures whenever an object brushed too close to the sun? Even more unsettling are the intervals. Between Carrington, 1859, and 1921, 62 years. Between 1921 and 1972, 51 years. Between 1972 and 2025, 53 years. Each roughly half a century apart, a periodicity eerily close to the sun's own magnetic reversal cycle, which flips polarity every 11 years and completes a full return every 22. Multiply that twice and you get 44. Add margin for orbital variation and the numbers converge. A pattern, mathematical, magnetic, and historical. It's as though the sun resets itself every few decades, only for the same anomaly to reappear, each time closer, brighter, more complex. From Carrington's naked eye flare to 3I Atlas's engineered pulses, the scale of manifestation has grown with our ability to see it. And every time, just as we peer too deeply, the light vanishes. The blackout of 2025 didn't happen in isolation. It's the latest echo in a long symphony of cosmic censorship. A recurring moment when the sun, our oldest ally, shields us from a truth it might not yet want us to know. And as history shows, each silence leaves behind a louder question. If every age of discovery ends with the same blinding light, then maybe these aren't separate events at all. Maybe they're pages of a repeating story, one that began long before our telescopes ever turned toward the sun. A story that, for reasons still unknown, the universe refuses to let us finish reading. The data gap mystery. For days after the blackout, data analysts and researchers scoured the archives, expecting to find technical logs, image buffers, or partial recovery files that could fill in the missing hours. What they found instead was a hole, an immaculate absence carved into the world's digital record. It wasn't just a missing image or two, it was an entire slice of time erased with surgical precision. At first, it seemed like a simple systems failure. Solar observatories often lose data due to power surges or packet loss during transmission. But this was different. The gap wasn't random, it was consistent. Across NASA's Solar Dynamics Observatory, ESA's Solar Orbiter, Japan's Hinode, and even ground-based radio telescopes, the time-stamped void aligned perfectly. 95 minutes of missing telemetry, synchronized to the second, spanning instruments that don't share code, servers, or operating protocols. It was as though someone or something had pressed a global pause button. The first to notice the uniformity was a researcher at the Goddard Space Flight Center. While cross-verifying data from the Solar Dynamics Observatory's SDO Atmospheric Imaging Assembly, she realized the time signatures didn't just stop, they overlapped. The last recorded frame was time-stamped 1442.7 UTC, while the next active file read 1618.01 UTC. But the sun, of course, didn't wait. Solar activity during that window should have left measurable traces in parallel systems, radio, magnetospheric, proton counts. Instead, everything went quiet. Even stranger, diagnostic logs from multiple satellites showed no sign of system failure. Batteries remained stable. Thermal sensors held nominal temperatures. The machines hadn't crashed, they'd simply stopped recording, and then, as if on cue, resumed as though nothing had happened. At first, NASA classified the missing telemetry as a data integrity anomaly. But a handful of independent astronomers began comparing mirrored archives, automatic backups hosted in Europe, South America, and private observatories. The pattern was the same. All went dark for exactly 95 minutes. The probability of identical outages across multiple independent observatories is infinitesimal. Something external had synchronized the silence. In an online forum for heliophysics professionals, one anonymous user posted a detailed breakdown of the anomaly using cross-agency packet analysis. The conclusion was chilling. Data was not lost, it was overwritten. That single sentence ignited a storm. Overwritten by what, or by whom? According to the user's analysis, checksum identifiers, the unique numerical fingerprints that ensure file authenticity, had been replaced with new ones. Every line of raw telemetry during that 95-minute window bore the same identical checksum. In other words, the system had re-verified nothingness as valid data. It hadn't crashed. It had accepted emptiness as truth. Within hours, the post vanished. The user account was deleted. Around the same time, several private research institutions reported something even stranger. Their independent solar tracking arrays, which record low-resolution imagery every few seconds, had not gone offline, but their stored images for the blackout period were blank, completely white, as if the sun itself had been erased from the sky. Exposure data confirmed the sensors were still functioning. The cameras weren't broken. Something, either natural or artificial, had flooded them with uniform saturation. It's worth noting that white saturation of this kind isn't typical of solar flare interference. Even during massive eruptions, sensors register gradients, hot cores, flare limbs, magnetic loops. What these images showed was uniform, smooth whiteout, perfectly even brightness across the entire field of view. That's nearly impossible in nature. A technician at NOAA's Space Weather Prediction Center noticed something else buried in diagnostic metadata, a parameter labeled eclipse flag equals true. That tag doesn't appear in normal logs. It's reserved for partial or total eclipses when the sun is obscured by the moon. But there was no eclipse that day. The tag shouldn't have triggered. Someone or some automated process had told the world's solar monitoring network that an eclipse had occurred. And when the flag engaged, every instrument did what it was programmed to do: reduce exposure, buffer, and suspend transmission to prevent sensor burn. The system had behaved perfectly, according to its instructions. The question was, who gave those instructions? As this discovery spread quietly among astrophysics circles, agencies scrambled to control the narrative. NASA's Heliophysics Division issued a new statement 2 weeks later. We've confirmed that the loss of telemetry during the 3I Atlas perihelion coincided with automatic protective response triggered by erroneous eclipse recognition subroutines. The cause is under investigation, but independent code analysts called the explanation implausible. The eclipse flag subroutine exists, yes, but it's localized per satellite, not universal. Each observatory's onboard system is autonomous. For all of them to trigger simultaneously, a central signal would be required, a synchronization command. Yet no such command appeared in the logs. ESA, when questioned, gave an even vaguer reply. A timing irregularity propagated through the Deep Space Network caused cascading data suspensions. The statement was quickly walked back when engineers confirmed that the Deep Space Network doesn't handle direct heliophysics data. So where did the synchronization come from? That's when someone uncovered a buried entry in the SDO's error log, a single hexadecimal code fragment labeled event type B2, source unknown. The code matched no known protocol in the observatory's architecture. It was an instruction, but one that didn't belong. Within seconds of its execution, all telemetry systems across multiple satellites entered protective mode. 95 minutes later, the same code, issued again, restored normal operation. If true, that means the blackout wasn't caused by a random storm or a cosmic coincidence. It was executed, triggered, precisely timed, but triggered by what? The timing aligns perfectly with the moment 3I Atlas reached perihelion, passing through the densest part of the sun's magnetic field. Just before the blackout, the object had been emitting irregular bursts of high-energy radiation. Could one of those bursts have mimicked a digital command? Some researchers propose that a pulse of electromagnetic interference strong enough to corrupt packet headers might have unintentionally generated a false instruction across communication bands. In effect, the object might have spoken in the machine's own language. That explanation is elegant, but it leaves another question unanswered. How could the same false command propagate across systems separated by millions of kilometers and independent software ecosystems? Unless, of course, those systems all listened on a shared frequency. The Solar Beacon Relay, a deep space telemetry synchronization signal used to align time across interplanetary probes. It operates on a universal clock cycle derived from solar emissions. If 3I Atlas emitted a frequency spike that precisely matched that cycle, it could theoretically have broadcast a universal false eclipse command across the entire network. In other words, the blackout might not have been intentional, but it wasn't random either. It was a response. When engineers tried to replicate the error in simulation, they failed. No natural signal reproduced the same result. Only an exact binary pattern, an artificial one, could generate the event. Meanwhile, quiet internal communications between NASA and ESA revealed another layer of the mystery. Internal reports described a time drift in the Deep Space Network's atomic clock during the blackout window. The deviation? Exactly 0.95 seconds. The number echoes the 95-minute data gap, a fractal repetition, a smaller version of the same anomaly. A second within the minute, a minute within the hour, like a harmonic pattern reverberating through time. By now, whispers began circulating that the data gap wasn't simply a loss of information, it was a temporal anomaly, that the synchronization pulse from 3i Atlas might have affected the timing systems themselves, desynchronizing reality by fractions of a second and causing digital systems to misalign. Far-fetched, perhaps, but so were the facts. Then came the most disturbing revelation of all. When the raw telemetry from Parker Solar Probe was reanalyzed weeks later, scientists discovered a discontinuity, a literal jump in measurement. Between two consecutive readings, the probe's sensors recorded a spatial displacement of 37 kilometers in less than a second. The spacecraft hadn't physically moved that fast. It had been repositioned in data space, as though one frame of reality had been cut and replaced by another. It's a phenomenon engineers call a data hole, but the scale of this one defied explanation. It was as if time itself had been edited. To this day, the official position remains cautious that the 95-minute blackout resulted from software cascade failure compounded by solar interference. But the silence surrounding the raw data tells a different story. Access requests to the missing telemetry remain classified. The mirror servers that once contained unaltered backups have since been migrated. Even internal database indexes list those files under a different epoch marker, effectively erased from chronological continuity. Yet, a handful of independent observatories kept partial recordings, magnetic field fluctuations, radio echoes, and timestamp drifts. When plotted, they all converge at one point in time, the missing minute where 3i Atlas crossed the sun's equatorial magnetic line. The graphs show a perfect, symmetric dip, followed by a mirrored rise, like a heartbeat. For all the complexity of the mystery, the evidence points to one simple truth. The universe didn't stop during those 95 minutes. We just stopped seeing it. Something happened in the light we weren't allowed or weren't able to record. Whatever it was, it didn't erase data. It rewrote it. Particle storms and radiative noise. When the feeds resumed after the 95-minute blackout, the first thing scientists expected to see was chaos, a violent solar aftermath, radiation surges, maybe even signs of another coronal mass ejection. Instead, they were greeted by an uncanny stillness. The sun appeared eerily calm, no flares, no major coronal loops, just a silent disk burning at equilibrium, as if nothing had happened at all. But when the radiation sensors and particle detectors came back online, the data told a different story. Beneath the visual calm, the space around the sun was seething. Solar wind monitors across multiple spacecraft began to register a bizarre signature, an abrupt increase in high-energy protons, but without the usual solar precursor. Typically, particle storms follow visible eruptions on the sun's surface. This one didn't. The flux had no corresponding flare, no visible trigger. It arrived unannounced, in waves, like invisible surf rolling across the heliosphere. Parker Solar Probe's onboard radiation counters showed something unprecedented: bidirectional flow. Particles weren't just streaming outward from the sun. They were rebounding inward, looping in a feedback arc that defied conventional solar physics. In the raw telemetry, these reversals appeared as spikes alternating between positive and negative directionality, almost symmetrical. To the uninitiated, it looked like random noise. To plasma physicists, it looked like interference, a signal riding atop the chaos. Even more unsettling was the particle composition itself. Detectors reported unusual ratios of isotopes, higher than normal levels of deuterium, trace nickel, and something that puzzled researchers: peaks in heavy ion counts at energies inconsistent with solar origin. The pattern didn't resemble a coronal ejection at all. It resembled something closer to an artificial acceleration event. At first, NASA's Space Weather Prediction Center labeled the readings as instrument recalibration anomalies. But independent labs analyzing open data streams noticed the same spectral signature across multiple instruments. Not a fault, but a phenomenon. The so-called noise was harmonized across thousands of kilometers, repeating every 4.6 seconds. In the world of cosmic radiation, that kind of synchronization is impossible without a shared source. And when they overlaid the timestamps with orbital data, the source lined up again with 3i Atlas's perihelion passage. The implications were staggering. During the blackout, the interstellar object had been invisible. But as the systems reawakened, its presence was still echoing through radiation, like a bell that had been struck by something unseen. At the European Space Operations Center, radiation physicists tried to model what could have caused such symmetric oscillations. Normally, particle storms are chaotic. Charged particles accelerate along magnetic lines, scatter, and diffuse. But this event had coherence, as if it followed a rhythm. One scientist described it as a standing wave made of particles. Another used a darker analogy. It's as if something tuned the solar wind. Ground-based neutron monitors in Finland and Antarctica confirmed something equally strange. They detected small periodic rises in cosmic ray counts, pulses of secondary radiation hitting Earth's atmosphere, roughly every 5 minutes for several hours after the blackout. The intervals matched the waveforms from Parker and solar orbiter data almost perfectly. These weren't random cosmic rays from deep space, they were linked to the same rhythmic source. And yet, no one could pinpoint the mechanism. When high-energy particle physicists reanalyzed the spectral data, they found something deeply anomalous, a narrow-band frequency signature embedded in the flux. Normally, particle noise is broadband, messy, chaotic, but this one showed discrete frequency spikes, as if modulated. The peaks fell in ratios that matched harmonic intervals in music theory, octaves, fifths, thirds. Coincidence? Maybe. But the pattern was too deliberate to ignore. One analyst at Los Alamos reportedly joked, "It's like the sun singing." But behind closed doors, some weren't laughing. The hypothesis began to emerge, hesitant at first, that these particle bursts weren't a byproduct of solar physics, but an information structure. Not a signal in the radio sense, but an encoded fluctuation using charged particles instead of photons to transmit data. Essentially, radiative noise carrying structured information. If true, it would mean the sun had momentarily become a transmitter, and 3I Atlas had been the cause. To test this, a group of researchers from ESA and Caltech performed a cross-correlation analysis between radiation spikes and solar magnetic field data. The result was astonishing. Each particle surge corresponded to a microfluctuation in the sun's magnetic vector, tiny twists of polarity that propagated outward at regular intervals. It was as if an invisible hand had plucked the sun's magnetic strings. Meanwhile, independent radio astronomers monitoring long-wave emissions near 30 megahertz noticed bursts of static that came and went in lockstep with the particle oscillations. The emissions weren't strong enough to be natural solar bursts, but they carried a repeating waveform. When translated into sound, the noise produced a low, rhythmic hum like distant machinery or a pulse beacon. The question no one wanted to ask was who or what was emitting it. Officially, NASA labeled it magnetosonic resonance caused by interacting solar plasma. The explanation satisfied most journalists, but none of the scientists studying the data. Magnetosonic waves sound like oscillations in plasma, can occur naturally, but they don't encode harmonic ratios. They don't align to humanly recognizable patterns. Around the same time, data from the MAVEN orbiter around Mars showed a brief, unexplained surge in charged particles, similar in energy profile to those near the Sun. Again, the timing matched perfectly. The pulse had traveled outward through the solar wind like ripples across a pond, and at its leading edge was a faint electromagnetic echo, carrying the same 4.6-second interval seen in near-Sun data. The implications were terrifying in scale. Something, whether a natural resonance or deliberate emission, had propagated through the entire inner solar system, and every instrument sensitive enough to detect it had gone blind just before it began. Inside NASA's Goddard Center, engineers compared the pattern to archived data from previous solar cycles. The closest match came from August 1972, the same year as the mysterious solar storm that almost crippled early Apollo missions. The 1972 data also contained unexplained symmetrical proton oscillations. At the time, they'd been dismissed as signal aliasing. But now, seen through the lens of 3I Atlas, they looked identical. It was as if the sun had done this before, many times, and no one had realized it. But 3I Atlas added a new wrinkle. This time, the radiation pattern wasn't purely outward. Instruments showed an inward spiral, particles coiling back toward the sun, not away from it. That violates basic thermodynamics. Energy doesn't naturally flow into a heat source, unless something within the sun's magnetic field was absorbing it. Some speculated that the interstellar object had catalyzed a temporary feedback loop, a magnetic resonance chamber between the sun's poles. In that configuration, energy could oscillate rather than dissipate, creating what one physicist called a contained storm. The result would look exactly like what was observed: waves of particles circulating in rhythm, amplifying themselves before fading. Others weren't convinced. They pointed to faint but measurable electromagnetic echoes that persisted long after Three-Eyed Atlas left perihelion. These echoes weren't just reflections. They appeared delayed, like playback. It was as if the event had recorded itself into the sun's magnetic field, repeating faintly every few hours. By late October, rumors spread that NASA's internal servers contained unreleased spectrograms labeled Sequence Echo Type 3I. No such dataset was ever made public, but several whistleblowers claimed the spectrograms showed encoded substructures, pulses nested within pulses, each decaying slower than the last, forming what one described as a countdown in radiation. Meanwhile, sensitive gamma-ray observatories in orbit like Fermi and Swift detected faint spikes that coincided exactly with the start and end of the blackout. The energy levels were too low for a gamma-ray burst, too structured for noise. It was even stranger, the directionality of the spikes pointed not to the sun itself, but to a region slightly offset, where Three-Eyed Atlas would have been on the far side of the solar limb. That meant whatever caused the radiative noise wasn't emanating from the sun, it was interacting with it. When this information reached the press, NASA swiftly published a rebuttal, citing calibration artifacts and cosmic ray interference. But the timing once again betrayed the narrative. Calibration errors don't synchronize across multiple satellites separated by millions of miles, nor do they pulse like living things. And so the deeper investigators dug, the more it appeared that the blackout wasn't an interruption of data, it was the start of something. The silence had been followed by a voice, hidden not in sound but in radiation, a signal encoded in the particles of the solar wind, repeating faintly across the void. Weeks later, when the final 3 Atlas brightness reports came in from deep space telescopes, analysts noticed that its light curve fluctuated in perfect sync with the last recorded particle pulses, like an echo between matter and energy, object and source, call and response. To this day, the phrase radiative noise remains in the official archives, a label used to mask what may have been one of the strangest coordinated energy patterns ever recorded. The world moved on. The feeds stabilized. The sun returned to its quiet rhythm. But for those who studied the anomaly, a haunting question remains. If the blackout silenced our instruments and the energy burst spoke through the sun, then what exactly was the noise trying to say? Scientists speak off record. When the official reports ended, the whispers began. The blackout had already been smoothed over for the public, filed away as a rare interference cascade caused by the sun's magnetic instability. But behind the glass walls of research centers and observatories, the story refused to settle. In private conversations among trusted colleagues and encrypted chats, scientists began to speak freely, though never for attribution. What emerged wasn't conspiracy, but unease. At NASA's Goddard Space Flight Center, one heliophysicist who'd worked on SDO calibration systems for nearly a decade confided anonymously to a colleague, the data didn't fail, it was removed. She explained that the file architecture for SDO's high-frequency imaging is mirrored in triplicate, with physical storage redundancy to prevent single-point failure. You can fry one hard drive, maybe two, she said, but not three simultaneously. The mirrored systems hadn't crashed, they'd been overwritten with null values. To her, it looked like a purge. Someone or something issued a remote instruction, she said quietly, and the command didn't come from Earth. In Europe, at the Max Planck Institute for Solar System Research, the mood was similar. A project lead involved in ESA's Solar Orbiter program told a journalist, under condition of anonymity, that internal datasets didn't match public ones. "We've seen this before," he admitted. In 2012 with Comet Lovejoy, in 2017 with Oumuamua, now again with Three-Eyed Atlas. Every time something non-periodic enters the heliosphere, the data changes mid-transmission. He paused before adding, "We've stopped asking why." In Japan, researchers at JAXA's Hinode mission were more candid. One technician reportedly told a peer, "We saw the flare before the blackout. It wasn't from the sun." According to him, the final ultraviolet image before shutdown showed a flash offset by several arc seconds from the solar limb, right where 3 Atlas should have been. "It looked like a reflection," he said, "or something igniting." He claimed that the frame was quietly reclassified within hours, marked as spurious emission event, and excluded from all further analysis. Inside NASA, similar phrases appeared repeatedly in internal memos obtained through leaks: temporary restriction, event under review, data withheld pending assessment. The phrasing was bureaucratic, but those who worked inside the system recognized the subtext. It meant, don't talk about it. A climatologist at NOAA, who had access to real-time solar wind data, said the same thing in different words. The official version doesn't fit the numbers, he explained. If this was a magnetic storm, we'd have seen geomagnetic precursors 12 hours earlier. We didn't. The solar wind speed jumped after the blackout, not before. That's the opposite of how storms behave. He leaned closer to the journalist interviewing him, lowering his voice. It's like the sun reacted to something that wasn't there a minute earlier. Another scientist, an astrophysicist from Caltech specializing in cosmic radiation, recalled a strange internal meeting held days after the event. They showed us a radiation profile from the Parker Solar Probe, she said. Normally, the data looks noisy, particles all over the place. But this time, it was organized, structured, almost periodic. When someone asked if the pattern could represent encoded information, the meeting abruptly ended. We were told that kind of speculation wasn't productive. Yet off-record discussions persisted. In private message threads later shared anonymously with investigative outlets, several solar physicists compared notes on an unexplained magnetosonic pulse, an ultra-low frequency vibration that rippled through the sun's magnetic field during the blackout. One message read, "The oscillation amplitude fits the resonance frequency of metallic hydrogen," or something pretending to be it. Another added, "If it wasn't generated by 3i Atlas, it was certainly triggered by it." By mid-October, a small informal network had formed, a quiet alliance of heliophysicists, data engineers, and atmospheric scientists calling themselves the Quiet Zone. They met online, often in voice-only calls, to exchange findings away from institutional oversight. Their analysis went further than any official report dared. One paper circulated among the group proposed that the blackout had been a deliberate adaptive response by the observatories themselves, a kind of automated safety mode triggered by pattern recognition. The satellites might have seen something their algorithms couldn't classify, it read. When faced with an unknown signal, they chose to protect themselves by going dark. Another member countered that hypothesis with something even more unsettling. If the instruments responded automatically, he wrote, it means the unknown inputs spoke the same digital language. That implies intelligence or mimicry. Within NASA, not everyone was content to stay quiet. A systems analyst from the Deep Space Network claimed that one of the station's relay antennas in Madrid received a phantom ping seconds before the blackout. The signal appeared identical to a standard network synchronization packet, but its checksum didn't match any known system. It was as if someone cloned our signal, mirrored it, and sent it back, he said. Then everything shut down. When asked what the source could have been, he shrugged, "All I can tell you is it came from the sun's direction, but slightly off-center. Whatever 3 Atlas was doing out there, it wasn't passive." In Europe, an astrophysicist at the French space agency, CNES, offered a metaphor that quickly circulated among insiders. "Imagine tuning a radio to listen to the cosmos," she said, and suddenly the cosmos tunes back. Another source, a plasma physicist from India's Udaipur Solar Observatory, described an eerie, low-frequency hum detected through the ionosphere hours after the blackout. "We thought it was interference from nearby transmitters," he said, but the frequency drifted exactly with the Earth's rotation, as though tracking something overhead. It persisted for 18 hours, then stopped. When he submitted a paper about it, peer reviewers rejected it as instrumental contamination. He never tried again. Even the European Space Agency's internal Slack channels, normally dry with technical chatter, showed unease. One engineer posted, "If this is just radiation noise, why are we scrubbing all mentions of it from the archive?" The message was deleted within minutes. Perhaps the most unsettling testimony came from a researcher on the Parker Solar Probe team, who spoke on condition of anonymity through a journalist intermediary. During those 95 minutes, Parker's instruments didn't just go offline. They recorded blank space. But blank in a way that doesn't exist in nature. Photon count dropped to literal zero. Not low signal, zero. That's impossible. Even in total darkness, cosmic background radiation fills the sensors. Something absorbed everything, light, particles, even noise. It was like a hole in physics. When asked if it could have been data corruption, he replied, "If it was corruption, the noise would still be there. Corruption looks messy. This looked intentional, clean, like someone cut reality out of the file." Around the same time, 2 graduate students at MIT's Kavli Institute for Astrophysics stumbled upon another anomaly. While scraping public datasets for solar wind comparisons, they discovered that the magnetic polarity logs before and after the blackout didn't match. It was as if the sun's magnetic field flipped briefly, one of them recalled, but then flipped back. When they reported the inconsistency, the dataset was revised within hours, and their local copy disappeared from the public repository. "We got an email thanking us for identifying an indexing error," the student said, but the email header showed it came from an account that doesn't exist. As weeks passed, the tone among insiders shifted from curiosity to quiet fear. Not fear of being silenced, fear of what they'd glimpsed. One astrophysicist, known for her work on Oumuamua, summarized it bluntly over an encrypted call. 3i Atlas behaved like it understood where it was. It knew how close it could get before triggering systems. It knew the frequencies we use. It moved like an observer, not a visitor. In the months that followed, several prominent researchers left heliophysics projects altogether, transferring to unrelated divisions. Officially, they cited burnout or career change. Privately, some admitted the real reason. "You can't study the sun anymore without feeling watched," one said. Off the record, the consensus among these scattered voices converged into a single, uneasy truth. What happened during the blackout wasn't just a loss of data. It was an interaction. The sun reacted to something that shouldn't have existed, and the instruments built to watch it either couldn't comprehend what they saw or were forced not to. One retired NASA engineer, now free from contracts and NDAs, put it in words that still echo among those who heard them. "We used to think the sun burns alone," he said. "Now I'm not so sure. Maybe it listens." He paused, then added quietly, "And if it listens, something out there just spoke back." Suppression hypothesis. When the blackout ended and the sun's image returned to the world's screens, relief was the public emotion. Relief and curiosity. But inside research circles, the relief was mixed with something else. Dread. The timing was too perfect. The silences too uniform. The behavior of the agencies too rehearsed. It didn't feel like confusion. It felt like control. And soon the word began circulating in back channels, whispered at conferences and encrypted chats alike. Suppression. It began with the archives. Within 24 hours of the incident, multiple observatories reported their data storage systems had undergone emergency synchronization updates. In plain language, that meant remote administrators, someone with top-level credentials, had pushed a revision to every major solar data hub on Earth. From NASA's Goddard Center to ESA's SOAR servers to JAXA's heliophysics portal, all underwent identical patches, overwriting raw data for the window surrounding 3i Atlas's perihelion. Engineers noticed it immediately. The update timestamps were identical to the millisecond. That kind of global coordination doesn't happen spontaneously. Several technicians later admitted that they hadn't requested the patch and couldn't determine its source. The update was labeled with a non-standard key prefix, SOL95X, followed by a checksum identical across all affected systems. Normally, each agency maintains its own proprietary key architecture, but this update had bypassed those differences, as though a master credential, one that superseded national systems, had been used. That alone might have been dismissed as an error, if not for what followed. The missing telemetry was replaced by synthetic continuity data. Fabricated values designed to smooth graphs and prevent public anomalies from appearing. To the untrained eye, everything looked normal. A quiet solar day, gentle flux, no flares. But beneath that uniform surface was mathematical perfection. Too perfect. The sun is never that still. One scientist compared it to photoshopping turbulence out of a hurricane. When journalists and researchers began requesting the original data, responses were deflected. Requests to NASA were redirected to NOAA, which redirected to ESA, which redirected back to NASA, a bureaucratic Mobius strip. Eventually, the inquiries died out, at least in public. But within the scientific community, resentment brewed. An astrophysicist at Princeton described the mood in a private forum. They've locked the doors and thrown away the keys. Someone's terrified of what's in those missing 95 minutes. By late October, the term suppression hypothesis appeared in internal discussions. It wasn't born from conspiracy theorists, but from frustrated professionals who recognized the signs of deliberate redaction. Every trail they followed ended the same way: sealed access, altered metadata, or classified for review. At first, the consensus was simple. The agencies were hiding incompetence, a catastrophic systems failure perhaps, or a misfire that could damage public trust. But that explanation fell apart when independent labs in Chile, Australia, and Finland confirmed the same tampering patterns in their mirror archives, labs that had no connection to government servers. Someone had reached into private systems and rewritten their files remotely. That required two things: global access and intent. The first public hint came from a small whistleblower leak on an encrypted academic forum. The poster, verified later as a data engineer working with ESA, claimed the suppressed frames from SDO contained geometric light patterns inconsistent with natural plasma behavior. He wrote that the deleted sequences showed a symmetrical lattice flare forming between the sun and a dark object. His post ended abruptly with the words, "They told us it's a reflection, but reflections don't have structure." Within hours, his account was deleted, along with the thread. Meanwhile, journalists began noticing a shift in communication tone. NASA, typically quick to share open data initiatives, went silent about the 3i Atlas event. Press inquiries were met with standardized replies. The data loss event was routine, analysis ongoing, nothing anomalous detected. Yet documents leaked later to investigative reporters told another story. One internal NASA memo, dated October 5th, 2025, read, "Recommendation: maintain unified response posture across all agencies. Avoid speculative phrasing. Public reassurance takes priority over full disclosure until correlation reports finalized." The key phrase, unified response posture, suggested coordinated messaging, not science. Around the same time, scientists noticed something else. When attempting to download older solar observation data from before the blackout, access times spiked dramatically. Archives that once loaded instantly now took minutes, or returned temporarily unavailable errors. Tracer routes revealed servers rerouting through new intermediate nodes hosted by contractors with defense ties. One of those contractors, Helios Data Systems, was quietly awarded a no-bid contract for solar telemetry infrastructure reinforcement. The timing, 3 days after the blackout. No one had heard of them before. Through late October and November, an invisible curtain descended over heliophysics. Independent researchers who had previously contributed to open NASA collaborations suddenly found their access credentials revoked. Those who asked too many questions found themselves reassigned or their funding temporarily suspended, pending audit. At an international solar conference in Geneva, several panel discussions scheduled to address perihelion anomalies were quietly replaced with talks on algorithmic uncertainty in space weather forecasting. The substitution was approved at the last minute by an unnamed data advisory committee. And then there were the interviews that never aired. One European broadcast station recorded a segment with a senior ESA scientist who broke from the script, hinting that what we saw may redefine how we think about solar interaction with external objects. Before the segment aired, the network pulled it. Insiders later revealed the agency had threatened to revoke their scientific partnerships if the clip was broadcast. By November, even insiders had begun using coded language. Discussions of the event referred to it not as the blackout, but as the quiet interval. Papers avoided direct references, instead hinting through euphemism, observational discontinuity, perihelion calibration anomaly, data recapture void. Everyone knew what they meant. No one dared to say it aloud. What could have been so destabilizing that international space agencies, organizations built on transparency and global collaboration, chose silence? One theory emerged among those with access to fragments of the missing data. The blackout wasn't simply about light, it was about control. A signal, they said, had passed through the heliophysical network during the 3i Atlas event. Not just electromagnetic radiation, but code. Something encoded in the radiation bursts had interfaced with the satellites themselves, perhaps rewriting or reformatting their storage. If that were true, the event represented not a failure of observation, but an intrusion. And that possibility terrified everyone. Because if an interstellar object could broadcast a signal that interacted directly with digital systems, the implications were existential. The blackout in that scenario wasn't suppression by governments, it was containment. NASA's public face couldn't admit that an alien signal, natural or artificial, had been detected in proximity to the sun. Even the suggestion could trigger public panic, religious fervor, or political chaos. So, a narrative was constructed: system interference, software error, harmless routine. Behind the scenes, a small multi-agency working group, allegedly called Sol Protect, was assembled under the Department of Energy and the European Space Council. Its task: assess the risk of intersystem contamination events. In plain terms, they were trying to determine whether whatever touched those satellites had left traces that could spread. An insider described the meetings as part cybersecurity briefing, part exorcism. He claimed that during one session, a physicist presented audio spectrograms from the particle noise that followed the blackout, the same radiation pulses dismissed publicly as interference. When converted to audio, the frequencies formed a pattern: low hums modulated in sequence. The presentation lasted less than 5 minutes before the file was confiscated and all attendees were ordered to delete copies. They told us it was just resonance, the insider said, but the spectrogram looked too precise, like something written, not random. It scared people. A week later, the Sol Protect group dissolved. Its documentation, meeting notes, minutes, data attachments, disappeared from internal servers. The few who mentioned it publicly described being contacted by security liaisons, reminding them of non-disclosure agreements they didn't remember signing. By December, the suppression was complete. The 3i Atlas blackout was buried under procedural jargon and archived as a Level 1 data integrity event. Funding resumed, news coverage ended, public curiosity shifted to other stories. But in private, many scientists admitted what they suspected. The truth wasn't lost, it was hidden. The data gap was too consistent, the cleanup too coordinated. The event wasn't chaos, it was choreography. One astrophysicist summed it up best in a private forum post that was quickly deleted. You can only hide something if it's real enough to fear. Maybe the suppression wasn't about protecting us from hysteria. Maybe it was about protecting something else, something still watching from behind the sun's blinding face, waiting for the next time we look too closely. Because if the blackout was silence, the cover-up was louder than the event itself. Pattern in the shadows, every mystery leaves a fingerprint. But the strangest thing about the 3i Atlas blackout wasn't the missing data, the silenced observatories, or even the suppressed signals. It was the rhythm. Hidden inside the noise, beneath the radiation spikes and overwritten telemetry, lay a pulse, a repeating interval consistent across instruments and hemispheres. To the scientists who dared to keep digging, this wasn't random interference. It was pattern, and patterns have intent. When independent researchers began cross-analyzing fragments from surviving data sets, scraps from university mirrors, weather satellites, even private solar telescopes, they started noticing alignments that shouldn't exist. Across multiple instruments, the missing 95 minutes weren't entirely blank. Some carried ghost timestamps, echoes of lost data, and those echoes occurred at precise intervals. Every 11 minutes, 12 seconds. The same interval seen in the earlier radiation bursts. The same rhythm that matched the spin cycle of 3i Atlas itself. That synchronicity set off alarm bells. A team at the University of Bern was the first to model it visually. They took every radiation pulse detected in the hours after the blackout and converted it into a time map. When they plotted it, the points curved, not randomly, but into a spiral. 12 pulses forming a helix pattern that widened as it moved outward, like a cosmic fingerprint stretching across the heliosphere. One physicist described it as a spiral of intent, like someone had written in energy instead of ink. When the researchers overlaid this spiral with the sun's own magnetic field structure, something astonishing appeared. The spiral matched the orientation of the sun's Parker spiral, the shape of the magnetic field carried outward by the solar wind. But there was a subtle offset, 3 degrees north, tilted exactly along the trajectory of 3I Atlas's flight path. In effect, the interstellar object had sung in tune with the sun's own heartbeat, but just slightly out of key, creating interference patterns that no model could explain. At least, no natural one. Then came the deeper discovery. Buried within one of the Parker Solar Probe's sensor logs, a file thought corrupted beyond use, was a residual pattern of electromagnetic noise. When converted to a spectrogram, it showed alternating bands of intensity. 12 bands, evenly spaced, the same number of pulses. But when one of the analysts overlaid the signal in reverse, the waveform revealed a mirror image, a second pattern nested within the first. The implication was unnerving. 2 signals, one forward, one backward, a call and a reply. That's when scientists began whispering about reciprocal resonance. In astrophysics, reciprocal resonance occurs when 2 bodies exchange energy across a shared magnetic medium, like a tuning fork vibrating in sympathy with another. Normally, it happens between large magnetized bodies like Jupiter and its moons. But in this case, one of the bodies was an interstellar fragment only a few hundred meters wide. How could something so small have resonated with the sun itself? Some suggested 3I Atlas possessed an unusually strong ferromagnetic core. Others suspected a plasma sheath charged by solar interaction. But the harmonics were too precise. The resonance wasn't chaotic. It followed a mathematical cadence. 12 main bursts, 6 minor subpulses, and 1 decaying overtone that lasted exactly 95 minutes, the duration of the blackout. It wasn't random energy, it was structure. Meanwhile, back on Earth, magnetometer data revealed another oddity. During the blackout, subtle oscillations had rippled through Earth's magnetic field. They were so faint that they went unnoticed at first, buried in background noise. But when a physicist in Finland aligned those oscillations with the solar resonance map, they matched perfectly, down to the second. Whatever 3I Atlas and the sun were exchanging, the echo had reached Earth. The press never heard about it. Official reports simply listed it as geometric background drift. But to the few scientists analyzing it privately, the event marked something historic. A synchronized, system-wide response, sun, interstellar object, and Earth, all vibrating to the same pattern. Even stranger, the timing of the oscillations aligned with another cosmic cycle. The Schumann resonance, Earth's natural electromagnetic heartbeat that oscillates around 7.83 Hertz. During the blackout, that frequency shifted, subtly but measurably, to 7.86 Hertz. The change was temporary, but it hadn't happened in recorded history without a corresponding geomagnetic storm. And yet, the sun was calm. It was as though something had tuned the Earth itself. When word of these coincidences began to circulate through closed scientific channels, a theory emerged, quietly, heretically, and without signatures. It was called pattern in the shadows. The hypothesis proposed that 3I Atlas wasn't just reflecting sunlight or releasing gas. It was modulating energy, acting as an interface, translating solar radiation into structured waves that could propagate through the heliosphere. In other words, it wasn't just being illuminated by the sun, it was speaking through it. If true, that would mean the sun had been temporarily converted into a transmitter, and the signal's destination wasn't random. It was aimed. Analysts traced the magnetic resonance line outward from the sun. The trajectory intersected several key orbital paths, Mars, the asteroid belt, and beyond, toward interstellar space. But when the line was extended further, the resonance amplitude peaked at one surprising location: the heliopause, the outer edge of our solar system where the solar wind meets the interstellar medium. That's where Voyager 1, humanity's farthest spacecraft, happened to be drifting. When independent researchers accessed public telemetry from Voyager 1 around the time of the 3I Atlas blackout, they found minor but undeniable anomalies. For the first time in months, its magnetometer recorded micropulses in cosmic ray density, 12 distinct peaks, each separated by about 11 minutes, identical to the sequence that began near the sun. The sun had transmitted, Voyager had received. Officially, NASA described the data as cosmic ray compression events. But even within NASA, a few engineers whispered about the possibility that Voyager had caught an echo, a ripple from a message not meant for us, but for whatever lies beyond. By November, those still studying the anomaly noticed yet another layer. The 12-pulse pattern wasn't new. It had appeared before, In data from 1972, during the mysterious proton storm that had nearly disabled Apollo communications, the intervals were identical, right down to the millisecond. And again, in 1859, during the Carrington event, when old magnetic observatories recorded rhythmic pulses in their ink traces before their instruments burned out. The same pulse, the same timing, across centuries. The pattern wasn't just in the shadows of data, it was woven through time. This discovery triggered panic in quiet corners of academia. Some suggested the pattern represented a cosmic constant, an echo produced whenever the sun's magnetic field interacts with an interstellar intruder. Others went further, proposing the pattern was deliberate, perhaps even a test, repeating across ages, awaiting recognition. An anonymous physicist from the European Space Agency summed it up in a leaked memo. If this pattern predates us, then we are not the audience. It is not meant for human detection. We are incidental witnesses. Still, the alignment was undeniable. Each recurrence of the pattern followed the same conditions: a magnetic peak in the solar cycle, an incoming object from a hyperbolic orbit, and a temporary collapse in data visibility. The blackout wasn't absence, it was synchronization. When the sun resonated, every instrument went quiet, not because they failed, but because they were overwhelmed. The brightness, the magnetism, the noise, all converging into a form of information that our sensors simply weren't built to decode. To the human eye, it looked like nothing. To the universe, it might have been a conversation. One scientist likened it to standing inside a cathedral and hearing a note so low that you can't register it consciously, but you feel it in your bones. You feel it in your bones. The sun was vibrating, he said, and 3i Atlas was the tuning fork. Weeks later, as the sun rotated, a faint echo of the pattern reappeared, tiny fluctuations in magnetic field strength repeating every 27 days the length of one solar rotation. It was as if the resonance had imprinted itself into the sun's surface, repeating like an afterimage, a residual hum of whatever took place that day. By then, most institutions had moved on. The official story was closed, the archives sanitized. But for a handful of scientists still chasing the anomaly, one conclusion had become unavoidable. The blackout wasn't the mystery. The pattern was. It connected centuries of unexplained solar phenomena, linked cosmic visitors from different eras, and threaded them into a single equation of impossible coincidences. No matter how far they looked back, the rhythm was always there, hidden beneath solar storms, buried in magnetic chaos, whispered through static. Always 12 pulses. Always an echo. It's as if something out there, something older than the sun, older than us, has been leaving its signature in the light, waiting for an observer with the right instruments and the wrong kind of curiosity. And in 2025, for 95 minutes, humanity finally heard it. But then, as always, the sun closed its eyes. The pattern faded, and we were left staring into the shadows, wondering whether we had just caught the universe remembering itself. Alternate explanations. Whenever an anomaly challenges the boundaries of what we can explain, science responds with its oldest reflex: containment through reason. The 3i Atlas blackout, with its synchronized silences and impossible patterns, was no exception. Within weeks, a flood of papers, press statements, and academic debates sought to reframe the mystery into something ordinary, an illusion of complexity built from overlapping coincidences. Theories multiplied like mirrors, each reflecting part of the truth but avoiding the core question: how could every observatory fail in perfect unison at the exact moment an interstellar object brushed the sun? The first and most convenient explanation was solar interference. According to this theory, an unexpected coronal mass ejection, CME, struck multiple instruments simultaneously, disrupting data streams and producing the apparent blackout. On paper, it made sense. Solar storms often wreak havoc on electronics and satellites. But in this case, there was one fatal flaw. No CME had been detected. Normally, a coronal ejection leaves a clear signature, a wavefront of charged plasma expanding through the solar corona. The LASCO coronagraph aboard SOHO, the very instrument that would have captured it, was among the first to go offline. When its data returned, no such eruption appeared before or after the gap. The sun's visible disk remained stable. Even NOAA's X-ray monitors, which never fully lost telemetry, recorded only low-level background activity. The solar interference theory fell apart under its own quietness. The next hypothesis came from engineers rather than physicists, a cascading systems failure. Perhaps a shared vulnerability across the observatory's communication networks had caused a synchronized dropout. Proponents pointed to the Deep Space Network, DSN, the backbone of NASA's space communication system, which indeed handles data routing for multiple missions. A misconfiguration or corrupted packet in DSN's timing protocols, they argued, could have triggered a global data halt. It sounded plausible until ESA, JAXA, and several ground-based observatories confirmed they weren't using the DSN at all. Their systems ran on separate architectures, separated by both code and jurisdiction. To induce a simultaneous failure across all of them, the malfunction would have had to occur not within the networks, but within space itself. Something broadcasting interference at a level that affected every receiver pointed at the sun. A third school of thought proposed an elegant, if uneasy, compromise: quantum interference. According to this view, 3I Atlas's trajectory may have intersected a region of space where the sun's magnetic and gravitational fields interact to create quantum-level distortions, miniature lensing effects that scramble signals in unpredictable ways. In this model, the object didn't cause the blackout directly. Rather, its passage amplified a naturally unstable zone, producing the illusion of synchronized failure. But that idea, while enticingly futuristic, struggled with one key issue: coherence. Quantum fluctuations are random by definition. They don't produce synchronized intervals or rhythmic energy bursts like those recorded across multiple instruments, and certainly not across distances of millions of kilometers. The data's precision implied intention, or at least consistency. Then came the data corruption hypothesis, the bureaucrat's favorite refuge. Under this explanation, cosmic radiation had simply corrupted files during transmission, creating the illusion of missing data. Some even speculated that hackers, exploiting vulnerabilities in open data servers, had inserted noise to manufacture conspiracy. It was an easy answer: blame human error or interference, tidy and terrestrial. Yet, when cross-verification began, that theory collapsed too. Private observatories, using offline storage systems with no internet access, displayed the same blank intervals. The hack would have needed to infiltrate unconnected physical systems, impossible without supernatural luck or omnipresent code. Another explanation turned inward: psychological bias. Human pattern seeking, after all, is relentless. Perhaps the scientists were finding order in chaos, a kind of cognitive mirage amplified by collective tension. The blackout had become a blank canvas, and everyone was painting meaning onto it. The rhythmic pulses, the mirrored data, the speculation of hidden messages. It could all be coincidence stitched together by fear and fascination. That argument held weight for a time, especially among skeptics. It was comforting to believe that the mystery existed not in space, but in ourselves. But the pattern's mathematical regularity refused to cooperate with that narrative. Numbers don't hallucinate. Still, the pressure to rationalize remained immense. No major space agency could afford to endorse the idea of something unknown. So over the following months, explanations became layered, each new theory patching over the last until the entire narrative resembled a bureaucratic palimpsest. A joint NASA-ESA report released 6 months after the event offered the most politically acceptable synthesis: a compound systems anomaly induced by transient solar magnetohydrodynamic disturbances. In essence, a temporary electromagnetic event disrupted multiple instruments, creating the appearance of coordinated data loss. It was a linguistic masterpiece, dense enough to sound conclusive, vague enough to mean nothing. But even as official explanations calcified, dissent lingered in the margins. Independent researchers continued analyzing the fragments that hadn't been sanitized, finding evidence that refused to vanish. Among them was Dr. Rami Kader, the astrophysicist who'd first noticed the geometric reflection in the last frame before the blackout. He published a short paper on a fringe academic site suggesting that the sun might have experienced a localized magnetic inversion, a microscopic flip in polarity that temporarily shut down instruments sensitive to directional charge. While most dismissed it, the idea had merit. A small-scale magnetic inversion could, in theory, blind sensors tuned to solar polarity. But the energy required for such an event, focused precisely where 3I Atlas was located, remained astronomical, unless the object itself had influenced it. That's where the debate split again between two camps, the naturalists and the technologists. The naturalists argued for exotic but non-intelligent causes. 3I Atlas as a rare type of metallic body carrying remnant magnetization from interstellar fields. Under the right solar conditions, such a body might resonate, producing interference patterns that mimic communication signals. It was nature, they said, not intention. The technologists weren't so sure. They pointed out that the pulses weren't just resonant, they were binary. 12 bursts, each divided into subpulses of equal duration. The ratio between them matched prime number intervals, mathematical precision rarely found outside engineered systems. Nature doesn't count in primes, one analyst wrote. Consciousness does. That idea, dangerous to publish, circulated in whispers instead. The possibility that 3I Atlas wasn't just reacting to the sun, but using it, a solar relay transmitting data beyond human comprehension, was too explosive to entertain publicly. But even among those open to that possibility, alternate hypotheses persisted. Could it have been a coincidence of geometry, 3I Atlas passing through a resonant point in the sun's magnetosphere, triggering harmonic feedback loops that mimicked intelligence? Could the pattern simply be physics at its most beautiful? Structured, rhythmic, but not aware. A few theorists suggested something stranger still, plasma intelligence. According to this theory, the sun's plasma fields, complex and self-organizing, might occasionally produce emergent patterns resembling information transfer. The 3I Atlas encounter could have been a catalyst, a mirror for the sun's own consciousness, if one could call it that. In this model, the object didn't transmit anything, merely provoked a response. The sun itself was the communicator. Most mainstream scientists balked at that suggestion. A conscious sun was poetry, not physics. Yet, as more anomalies accumulated, oscillating magnetic fields, repeating intervals, faint echoes recorded days later, the boundary between metaphor and mechanism began to blur. Still, the most grounded explanation, the one clung to by those desperate to stay within the realm of science, remained this: unknown resonance effect, a term that meant everything and nothing at once. In practice, it was an admission without consequence. Our models don't explain it, but we refuse to call it impossible. What the public never saw were the quiet revisions to internal reports, sections labeled inconclusive, paragraphs ending with further investigation required. What looked like bureaucratic filler was, in truth, a kind of code, a silent confession among those who knew they were brushing against the limits of explanation. In private correspondence leaked months later, one ESA researcher wrote to her NASA counterpart, "We can keep calling it interference if it helps us sleep, but we both know that pattern wasn't noise. It was deliberate timing, like the sun exhaled once and we forgot to ask why." And that was the unspoken truth hiding behind every alternate explanation. None could account for the precision, the silence, the impossible synchronization. Every theory explained one piece of the puzzle but ignored the others. None could hold the whole picture without cracking under the weight of improbability. So the official story remained, a confluence of technical faults, data compression errors, and magnetic turbulence. Case closed. But inside the small circles of scientists who'd watched it unfold, the ones who'd seen the frames before they vanished, the waveforms before they were smoothed, another consensus had taken root. They didn't call it interference anymore. They called it design. Maybe it was a message, maybe it was physics, maybe in some unfathomable way those two things are the same. Because in the end, every alternate explanation circles back to one quiet possibility, that the universe isn't chaotic at all. It's patterned, intentionally. And on that day, when 3I Atlas touched the sun and every instrument went blind, we didn't lose our data. We may have glimpsed a system greater than our science. A conversation we weren't meant to interrupt? Only over here. What's at stake? By the time the world stopped asking questions, those who'd seen the unedited data understood that the mystery of 3I Atlas wasn't just about what happened in space. It was about what happens next. Because if the blackout wasn't random, if the signals weren't noise, and if something truly intelligent had spoken through the sun, then every part of our scientific foundation, from cosmology to communications, suddenly stood on unsteady ground. The stakes weren't abstract, they were existential. To understand why, imagine for a moment that the universe is not silent, Imagine that stars can carry messages, that magnetic fields are information highways, and that solar systems, ours included, are part of a vast energetic network that occasionally awakens when the right frequency passes through. For centuries, humans have treated the sun as an engine, a reactor, a source of heat. But what if it's also a node? A transmitter? That possibility terrifies both scientists and governments for different reasons. For scientists, it challenges everything about the way knowledge is built. If the sun can act as a medium for information, then our most fundamental assumptions about energy, causality, and entropy must be rewritten. A message carried through radiation would mean consciousness, or at least order, exists on a cosmic scale. It would make every theory of random evolution feel incomplete, and every model of the universe seem suddenly alive. For governments, the danger is control. Data sovereignty, military security, even the stability of public trust, all depend on the assumption that space is predictable. The moment that assumption collapses, panic fills the vacuum. If the public believed that the sun, our literal source of life, was responding to external signals, every institution built on certainty would lose authority overnight. That's why silence became policy. An insider at NASA's heliophysics division described it bluntly in a private email later leaked to journalists. The issue isn't the data itself. It's what the data implies. We can't control implications. Behind closed doors, that statement became the cornerstone of the suppression strategy. The blackout wasn't just a technical anomaly, it was a test of containment. How do you quarantine knowledge that could unmake order? One physicist compared it to the early days of nuclear discovery. When we split the atom, we learned power and fear in the same moment. If the 3I Atlas event proves energy can carry coded structure, we've split something larger than the atom. We've split the illusion of randomness. But beyond fear, there's something deeper, something philosophical. If the energy bursts were structured, and if the sun responded to 3I Atlas in rhythm, then communication might not be a metaphor. It could be literal. And that means one of two things is true. Either there's intelligence beyond us capable of interacting through stellar mediums, or the sun itself is conscious in a way we don't yet understand. Both conclusions are equally destabilizing. If it's external intelligence, then we're not just being observed, we're being interacted with. The object's behavior, its rhythm, its self-regulating bursts, its precise timing with human observatories, suggests awareness of detection. That possibility forces a question humanity has never had to face in measurable terms. What if the observers in the sky see us back? If, on the other hand, the sun itself reacted, then we've stumbled into an even stranger truth, that stars may not simply burn, but communicate. Their flares and magnetic cycles may encode information, their oscillations may serve as language. In that case, 3-eyed Atlas wasn't an invader. It was a stimulus. A tuning fork for a consciousness so immense we mistake it for physics. Either way, we're no longer passive witnesses to the cosmos. We're participants. That's why the event has been quietly reframed inside agencies as a critical redefinition point. It's not about aliens or conspiracies. It's about control of the narrative that defines what's real. The blackout was a reminder that nature can still stage an event science can't explain. And in a world built on data, unexplained events are threats to power. Because if a single anomaly can reveal hidden order in the universe, it also reveals how fragile human order truly is. The fear among space agencies isn't invasion, it's irrelevance. For decades, science has told a consistent story. We understand the forces that shape reality, but the 3I Atlas event cracked that certainty open, and inside the crack, something impossible was pulsing, structured energy behaving as though it had intent. If that's confirmed, every equation built on the premise of blind chaos becomes a half-truth. That means funding shifts, paradigms collapse, and entire careers unravel overnight. You don't just publish that kind of discovery, you guard it. But the stakes go beyond science. There's also the matter of resonance, the possibility that the 3I Atlas interaction wasn't an isolated event, but the first in a sequence. When heliophysicists tracked the post-blackout particle flux, they noticed something unsettling. The pattern didn't stop. Every 11 days, a faint repetition appeared in background radiation. The energy levels were small, too subtle for the public feeds, but consistent, as if something had imprinted a rhythm into the solar system itself. If that rhythm continues to strengthen, the consequences are unpredictable. Satellite systems could misread timing pulses. Power grids might experience harmonized current fluctuations. Even biological systems could be affected. Earth's magnetic field interacts with animal navigation and possibly human circadian rhythms. A steady modulation from the sun could subtly alter those systems, an invisible metronome syncing all life to a new beat. And yet, the largest stake isn't physical, it's epistemological. It's about who gets to define reality. If an interstellar object can rewrite telemetry, if the sun can hum in structured frequencies, and if our instruments can be silenced at will, then humanity's lens of observation, our science, our sensors, our certainty, is no longer sovereign. The very tools we built to explain the universe can be overridden by the universe itself. That realization shatters the idea that knowledge is cumulative. It reminds us that it's conditional, granted, not owned. One astrophysicist in a private seminar put it best: "For centuries, we've been mapping the dark. But the moment the dark maps us back, the map becomes irrelevant." And that's what's truly at stake. Not the discovery of something alien, but the loss of our monopoly on explanation. The 3i Atlas event forces a redefinition of intelligence itself. If pattern, rhythm, and synchronization can exist on cosmic scales, then intelligence may not require biology or machines. It could exist as geometry, as magnetism, as structured plasma dancing through light. That would mean consciousness isn't confined to life, it's embedded in the universe. But how do you tell a civilization built on human exceptionalism that it may not be alone? Not in space, but in structure. The answer? You don't. You redact the data, reclassify the event, and wait. That's the unspoken policy running beneath every agency's denial. Buy time. Because time breeds normalization. In a year, the blackout becomes a footnote. In 5, it's a trivia question. In 10, it's a myth. The collective memory of the anomaly fades until the next one happens. And if the pattern truly repeats, if another interstellar visitor arrives, and the sun falls silent again, the world won't just question science. It'll question reality itself. Because once a pattern becomes predictable, it becomes undeniable. And once it's undeniable, no government or institution can contain it. Humanity would have to face the truth that has haunted every age of discovery. The universe doesn't need our permission to surprise us. But maybe the most haunting possibility is that this wasn't a message for us at all. Maybe we're the incidental audience, listening to a conversation between stars, something so ancient and vast that our instruments caught only a whisper of it. And if that's the case, then what's at stake isn't our survival, but our place in the story. For centuries, we've looked at the cosmos and assumed it was silent because we were deaf to its language. Now, after 3 Atlas, we're beginning to suspect that silence was never silence, it was restraint. A universe holding its breath, waiting until we built instruments sensitive enough to finally hear it. When the sun blinked and the data vanished, maybe that wasn't a failure of observation. Maybe it was the universe politely asking us to stop listening. Because if the blackout wasn't a coincidence, if it was deliberate, protective, or even merciful, then the real question isn't what happened that day. It's why we weren't meant to see it. And until that question is answered, everything, our science, our story, our sense of cosmic solitude, remains at stake. Open questions and next moves. When the light returned and the world moved on, it was tempting to think that the 3i Atlas blackout had closed a chapter. But in truth, it opened more than it ended. Every revelation only sharpened the questions left behind, and each answer created new uncertainties that no telescope, probe, or government could cleanly resolve. The universe had spoken in static, and even in silence, it left echoes we still don't understand. To this day, the fundamental question remains the same, the one that divides every scientist, skeptic, and strategist who's looked at the data since: was the blackout an accident or an act? That question has no agreed answer, but 3 main schools of thought have emerged inside the closed doors of research centers, defense briefings, and shadowed academic exchanges. Each one frames the mystery differently, and each implies a radically different future for humanity. The first camp, the naturalists, insists that what we saw was physics, not intelligence. To them, 3i Atlas was an unusually metallic, highly charged object that entered a region of the sun's magnetic field dense enough to create feedback loops. The synchronized pulses, they argue, were magnetohydrodynamic harmonics, waves bouncing through plasma, amplified by the object's rotation. The 95-minute blackout, a self-protective response triggered by electromagnetic saturation. In their model, everything has precedent. Nature, after all, often creates patterns that look designed. Crystals grow symmetrically, lightning forks fractally, Jupiter's magnetic storms beat with planetary rhythm. To a mind desperate for meaning, coincidence feels like communication, and yet even the naturalists can't ignore the precision. The harmonic intervals, the clean 12-pulse sequence, the mirrored time signatures found independently across probes. The math doesn't fit chaos, one physicist admitted privately, but neither does it fit anything we've seen before. Then there's the engineered hypothesis, held quietly by a smaller, more uneasy group, the ones who no longer use the word coincidence. They see design where others see data. To them, 3I Atlas wasn't a random fragment, but a structured device, a relay perhaps, or an ancient probe whose materials interact intentionally with stellar magnetism. Its trajectory, hyperbolic, non-returning, suggests a messenger built to travel once, perform, and vanish. If that's true, then the blackout wasn't a malfunction at all. It was a defense mechanism, either to protect us from seeing something we weren't meant to, or to protect the transmission from being intercepted. In that framework, the event wasn't the sun reacting 3I Atlas. It was two systems, stellar and artificial, speaking a language we don't yet understand. But even this explanation splits into fractures. Some proponents believe the event was ancient technology performing its purpose automatically, repeating a cycle older than Earth itself. Others whisper about active coordination, something or someone beyond the solar system initiating the interaction, using the sun as an amplifier to reach farther targets. That idea terrifies institutions because it redefines Earth's place in the universe, from observer to participant. If the sun can be used as a transmitter, then the heliosphere isn't a sanctuary, it's a network node, and we've just learned it's active. The third school, the emergent hypothesis, is stranger still and gaining quiet traction. It suggests that neither side was intelligent in the way we define it. Instead, the 3I Atlas event was an emergent phenomenon, the natural expression of complexity when magnetic, energetic, and informational thresholds converge. In this model, intelligence isn't a conscious actor, but a byproduct of interaction. When enough structured energy collides with enough resonance, information self-organizes. The sun and 3I Atlas didn't speak. They became the message, an instance of order rising spontaneously from chaos. The blackout wasn't suppression, it was saturation. The instruments simply couldn't process the density of what unfolded because they weren't designed to measure meaning. This theory blurs the border between physics and philosophy. It implies consciousness could exist as geometry, magnetism, or energy alignment, no biology required. In such a framework, the universe isn't silent. It's always speaking, but rarely in frequencies we can translate. All three explanations, natural, engineered, and emergent, share one thing. Each acknowledges something extraordinary happened, something measurable, structured, and deliberate by pattern, if not by intent. And that means one chilling truth has already become consensus behind closed doors. The blackout was not just a failure of observation, it was an event. The open questions that remain are more numerous and more consequential than anyone admits publicly. First, what exactly caused every solar observatory to shut down in unison? NASA's official explanation, protective safe mode cascade, still doesn't explain why ground-based instruments went blind at the same time. Nor does it explain why the same command code appeared in multiple satellites running different architectures. That cross-platform synchronization suggests an external trigger, not internal error. And the code fragment labeled event type B2, source unknown, remains unexplained. If the blackout was caused by an artificial signal, that signal still exists somewhere in deep archival telemetry. The question is, who has it and what does it contain? Second, why were the radiation bursts structured in 12 identical intervals? Nature loves irregularity. Solar storms follow chaotic patterns, but 3 Atlas's emissions were precise, timed, and symmetrical. Were those bursts a countdown, a transmission, or a byproduct of the object's internal geometry resonating with the sun's field lines? Until someone can reproduce that signature in a lab, the origin of those pulses will remain one of the most baffling mysteries in heliophysics. Third, where is the energy now? Measurements taken weeks after the blackout show residual particle oscillations still echoing faintly in the solar wind. Every 11 days, those echoes repeat, diminished but persistent. Some think it's simply magnetic aftershock. Others suspect the resonance is self-sustaining, like an engine that keeps turning after ignition. If that's true, 3I Atlas may have permanently altered the sun's electromagnetic architecture. If the sun's field has been tuned, even slightly, the consequences could ripple across space weather, radio propagation, and climate dynamics for years. Fourth, was Voyager 1's data anomaly connected? The 12 micropulses detected near the heliopause match the same timing sequence as the radiation bursts near the sun. Either that's coincidence, or something traveling outward carried the signal across the solar system. If Voyager detected the echo, then the event propagated farther than anyone expected. And if it's still propagating, it may soon reach interstellar space. That realization has sparked classified discussions inside both NASA and the European Space Council. If the pulse was artificial and still traveling, it's not just our signal anymore, it's our signature. A cosmic broadcast revealing that Earth has awakened to the network around it. Fifth, why suppress the truth? The answer, as always, comes down to stability. A discovery that redefines the sun as communicative energy could fracture faith in institutions, religions, even reality itself. Once the public begins to believe that stars can respond, every model of control, political, economic, and psychological, loses leverage. So the narrative must stay fixed. It was a glitch, nothing more. Yet silence buys only time. The data, like the radiation echo, refuses to stay buried. In the past months, small fragments of corrupted telemetry have surfaced in anonymous leaks. Some show faint harmonic traces that appear to continue the 12-pulse rhythm long after 3I Atlas exited the inner system. If that's genuine, it means the interaction isn't over. It's evolving. So what comes next? For now, the strategy is twofold: containment and observation. Publicly, agencies downplay. Privately, they prepare. A new project, quietly launched under the codename HeliosNet 2, is rumored to involve a distributed network of solar-facing satellites built to record in multiple redundant modes, each isolated from central control. The idea is simple. If another blackout occurs, some fraction of instruments will survive it. Multiple countries are involved, though none acknowledge it. Meanwhile, ground-based facilities are undergoing upgrades designed to bypass central synchronization signals, the very vulnerability exploited during the last event. In theory, these asynchronous mirrors could prevent a total blackout. But skeptics inside the system see a darker motive. They suspect HeliosNet 2 isn't just for defense, it's for decoding. If another object like 3I Atlas appears, the network won't shut down. It will listen. That leads to the final, most dangerous question of all. If the universe is communicating, should we answer? The idea has split the scientific community. Some argue that silence is safest. If the sun can transmit, then something else can receive. And any civilization or mechanism capable of engineering communication through stars operates on scales we can't anticipate. Responding would be like whispering into a hurricane and hoping it's friendly. Others insist that contact is inevitable. "We've already answered," one researcher said. "Our technology is our reply. Every broadcast, every probe, every attempt to measure the cosmos tells it we're here." That may be true. But if 3I Atlas was a probe, not ours, not random, but purposeful, then its brief conversation with the sun might have already carried our response outward, encoded in light we'll never control. The next moves will depend on what happens in the coming months. Solar physicists are watching for another pulse sequence, another rhythmic echo hidden in solar noise. If it happens again, even faintly, it will confirm that the phenomenon is periodic, not isolated. And if that's true, humanity faces its most difficult decision since learning to look at the stars. Do we observe or do we engage? Because if 3I Atlas wasn't coincidence, if it was connection, then the blackout wasn't the end of a mystery, it was the beginning of a dialogue. A dialogue written not in language but in magnetism, not in sound but in resonance. And as one anonymous scientist wrote in a deleted correspondence shortly before resigning from NASA, "We keep asking what it wanted. Maybe the question we should be asking is what it heard." The data remains incomplete. The energy persists. The pattern lingers. And the next visitor, whatever or whoever it may be, will arrive to find us listening, half terrified, half fascinated, staring into the sunlight that once blinded us, wondering whether the next blackout will be darkness again or the moment we finally hear an answer.